Excellent. All of my buttons keep moving this morning, which is slightly annoying. All right, so you should all see that welcome slide. And I lost my participant list, so I need that back. And so right when we hit 10 o'clock, we'll go ahead and start admitting folks from the waiting room and we'll get started. So thanks everyone for being here and looking forward to it. Here we go. Good morning, everybody. We're going to let everybody enter from the waiting room over the next minute or so, and then we'll go ahead and get started for today. All right. I think we've mostly got folks in the room from the waiting room. So welcome everybody back to day 2 of the Northeast RISC Symposium for 2026. We're really glad that you're here. Yesterday was really great from my perspective. We had lots of informative and thought-provoking sessions throughout the day, and we're ready with the same today. For those that weren't able to join us yesterday, I want to make sure that we extend a huge thank you to the symposium planning team. And I should introduce myself. I'm Jenica Allen. I am the director of the Northeast RISC and your symposium chair for this year. But I am your on-screen host right now with a huge team behind the scenes, making sure that everything goes smoothly, that questions get answered, and that we actually have the amazing lineup that we have today. So thanks to Matt Brinka, Hallie Harriman, Gabby Nunez-Mir, Isabella Reganes, Marian Rector, Shika Singh, Eduardo Tovar, and Emma Vanderheide. If you see them in the chat, please feel free to give them some thanks and some kudos. And for those that are joining us for the first time today, I know we had some first-time riskers registered for today's meeting. I want to make sure that we share our organizational mission with you, which includes synthesizing relevant science, sharing the needs and knowledge of practitioners, building stronger scientist practitioner communities, and conducting priority research to reduce the compounding effects of invasive species and climate change. I hope that if you're new to RISC, you'll watch our recording of Carrie Brown-Lima in her welcome presentation yesterday. We'll have those recordings up in the next month or so to gain an even deeper understanding of the organization and its history. I would be remiss if I didn't also acknowledge and thank our huge leadership team. So our leadership team of the Northeast RISC is largely volunteer. All of the people that you see on this screen are volunteering their time from 18 different organizations at present. That's really a range of federal and state agencies, academic institutions, NGOs, private companies. And it's really the work of these folks on the leadership team and all of you that make the Northeast RISC Network possible. So thanks to them and thanks to all of you for being here today. And I also mentioned briefly yesterday that 2025 was a productive year for the Northeast RISC, despite some pretty serious hurdles due to reprioritized research funding and organizational mandates. Bethany Bradley, our closing speaker yesterday, highlighted some of the good things that happened for the network, and I want to just talk about a few other of those highlights. And so Included in those highlights are 6 new research papers that were published to address topics that you as the network have told us are important for providing information and research and resources towards managing invasive species and climate change. It includes 20 research summaries to bring research to the network in really easily digestible formats with actionable takeaways. It included 2 new research to practice papers, which are really aimed at synthesizing current research and focus on particular topics. And last year's topics were managed gene flow and climate resilient native plants. And so if you haven't seen those research to practice papers, I highly encourage it. We've got a whole library of previously published ones too that are just really great, often 2-page resources that you can use for outreach, education, and self-education. We also hosted a whole variety of events that brought network members together to learn and discuss recent science and lessons learned from the field, really amplifying both the research and the practice of invasive species and climate change management. And the leadership team gave over 50 presentations about invasive species and climate change, science, and resources to our ever-widening community. And so that is one of the things that I want to make sure that we acknowledge and highlight today is that we are really aiming to and working hard to connect with folks that, squarely work in the invasive species space and are integrating climate change or are thinking about integrating climate change into their work, but also aiming to connect with folks that lead with climate change as the core of their work and integrate invasive species into that. And so if you have speaking opportunities, places where you think that, having invasive species and climate change research and resources represented is important, please let us know that. We're always looking for new ways to connect and bolster the network. One of the things that we started last year was an advisory group for the Northeast RISC. I mentioned we have a leadership team, and we're really fortunate to have some practitioners on our leadership team. Their voices are really important for helping the organization grow and respond to and adapt to the needs of on-the-ground management and planning. But we've also heard over the years that practitioners invested in the network needed a different way to provide guidance to the organization. And so this advisory group was created to meet that need and bring more of those practitioner voices into the leadership and decision-making of the organization. And so we're really grateful for the input that this group has provided so far. We've heard things like, don't stop talking about climate change, which was a weird conversation to have. But, in some cases, those are, that's a phrase that is discouraged. And so we will keep talking about it, even if sometimes we have to use different words in different venues. And we've also heard things like change how you post event summaries and how they're shared. And so we're working on that and changing our processes around how we get information out to the network based on the feedback that we're getting from this group. So I really want to thank these folks for stepping up and being a part of the leadership structure of the Northeast RISC. And finally, something that wasn't on the year in review, but I think is important to share, is the crafting of our first value statement for the Northeast RISC leadership team. So this was created through a workshop process with our leadership team and subsequent revisions of the output of that workshop. I'm putting the statement on screen now so that you can get a first look at that statement. And I'll highlight that it brings forward impactful science, collaboration, open-mindedness, and landscape resilience as the key tenets of our leadership team values. This value statement is now posted on our website, and so please feel free and spend a little bit more time with it if you want to see and think about in more detail where we've landed as a leadership team and what we think is important. But I appreciate that participants in this symposium have really approached conversations thoughtfully and listened with curiosity, and remembered that really we're all here doing our best to manage the interaction of two big global change challenges with science and experience as guides. So with that, I'm going to just transition into what you told us yesterday. If you had a magic wand, which invasive species would you make disappear? And this is the word cloud of your responses. It was interesting to see, we had a bunch of plants on the list. We also had some invertebrates and viruses and, beach leaf disease, which I guess is, nematodes and jumping worms. So this, gives us a little bit of food for thought of, species that, if we haven't created resources for, we can turn some attention to some of these species. I had a little bit of a chuckle. Someone said, I'm stretching the definition a little bit here, but I think deer overpopulation belongs on this list because it's really, really a big issue for revegetation. So thanks for sharing those perspectives. We're going to have another kind of fun poll at lunch today, and we'll share the results back with you before the end of the day. And this is where we're headed. We've got a couple different tools sessions this morning, a presentation session followed by some demonstrations and a lunchtime break again. And housekeeping reminders, we are in Zoom meeting format so that everyone can participate in this conversation. It also means that you can unmute yourself at any time. So please do stay muted while you are not one of the speakers or actively asking a question during a Q&A. We are recording presentations and discussions. And so if your video is on, you may be recorded. So if you would prefer not to be, you can turn your camera off. I will note that we have two presentations today that will not be recorded. They're sort of have communication plan rollouts coming. And so you may hear an audible notification that recording has stopped and then restarted during those presentations. We do have closed captioning available. Your toolbar may look a little bit different. You will either have this show captions button at the bottom, or this show captions might be underneath your little 3-dot more button. So if you'd like the live transcription, find that closed captioning button. And please share your perspectives in the chat during presentations, during Q&A, and also ask your questions either in the chat or by using the raise hand function, which you can find under the reactions button on your toolbar. If we've got folks that want to ask questions live, we'll aim to go back and forth between moderators reading questions from the chat and live questions. And that's the end of my housekeeping for this morning, the end of the welcome to day 2 of the 2026 symposium. And I'm going to turn it over to Matt Brinka to lead our first session.
Good morning, everyone. Welcome to our first session. This one is for tools for invasive species management in a changing climate. We have 3 great presenters that will be joining us today, and I've heard that there is a special conclusion to this session, so please stay on until the end. But I would like to first introduce Tawny, who is an extension educator with UMass Extension, and they will be presenting on invasive insect resources from UMass Extension. So take it away, Tawny.
Great. Thank you so much, Matt. And let me share my PowerPoint. Let's see here. Are folks seeing it in presenter mode or full screen?
We have full screen, or you are, no, we see presenter mode.
Okay, let me swap. Sorry, two monitors. All right, now I'm assuming we're good.
We're good.
Okay, great. Well, thank you so much for the introduction, Matt, and I'm really happy to be here, although very quickly today. And as usual, I have a lot to share. So I'm just going to be going very quickly and very briefly over a lot of different resources that UMass Extension has available, not only for invasive insect pests, but also some natives that outbreak occasionally as well. And again, my name's Tawny Simiski. I'm an extension entomologist with our landscape nursery and urban forestry program. And I structured this presentation under the assumption that maybe many of you don't know me yet. I apologize if you already do. These things won't be a surprise for you, but my main goal here is in 15 brief minutes to give a exceptionally short intro to a very small fraction of UMass Extension and the work that I focus on, along with some other entomologists in the state of Massachusetts. I'm going to go very quickly through a lot of freely available online resources that we have. I'll talk very briefly about our plant diagnostic lab as a resource, and then of course point folks to reporting, which this audience probably knows, but I have to I have to share it, especially when introduced insects or invasive insects are the topic. And then hopefully we'll have 5 minutes for audience questions and answers. If you're not familiar with our landscape nursery and urban forestry program, we provide continuing education to adult professionals in green industries in Massachusetts. So my stakeholders are primarily arborists, landscapers, folks doing property management in various capacities, nursery owners and operators, as well as urban foresters and state, federal, and nonprofit employees. So anyone who, for me, is interacting with trees and shrubs and then therefore having to, on occasion, manage insect pests associated with them. I'm not able to get into the history of extension at our land-grant universities. For those of you who know, it's a very lengthy history, and that we receive state and federal funding. And I just wanted to highlight that, we have a high population in the state of Massachusetts in a relatively small amount of land, and that my focus and the stakeholders that I serve are impactful contributors to our state as well as regional economy. This is some old information, but it's just a quick snapshot that we have a lot of firms, professionals that are doing this sort of work across the state, and these are the folks that I'm educating. And I just wanted to point out that, I'm located at the University of Massachusetts at Amherst. Every state in the United States has an extension service, and we're all set up a little bit differently. We haven't had county extension in Massachusetts since approximately the 80s due to some budget cuts back then. However, we are lucky to have two remaining county extension services in Plymouth County as well as Barnstable County. And I just wanted to point out, if you don't know them already, Blake Dinius is an entomologist with Plymouth County Extension, and the newest member of the team here is Escher Cattle, who works for Barnstable County or Cape Cod Cooperative Extension. So those two counties for our state are extra lucky that they have this support and these educational resources, particularly their expertise about ticks as well as tree and shrub pests. But that is not, unfortunately, the norm anymore for Western Mass or Central Mass or any other counties in our state. And so what do I spend my time doing? Well, I wanted to share the resources with all of you that are available for tree and shrub insect pests, and of course highlight that a lot of the non-natives, the introduced species that you're likely already familiar with, are ones that I spend my time talking to stakeholders about and providing information on how to manage them using integrated pest management, or IPM. I'm assuming many of you remember the most recent outbreak of spongy moth, or Lymantria dispar. And of course, this image shows the aftermath of mostly Entomophaga mimaiga, the fungus that helps regulate their populations typically. But I do think I see some inverted V's there, so some NPV virus as well. But this was back in 2017. And I'm sure you may remember that we had over 900,000 acres of defoliation across the state of Massachusetts from spongy moth alone that year. And this is a picture from July showing some of that activity. In recent years, we're responding to spotted lanternfly being introduced into Massachusetts, and in particular, in the last growing season in 2025, this insect has moved to many new communities in Massachusetts, and we're still asking folks to be aware of it and to make sure that you're reporting spotted lanternfly if you're seeing it. And it's becoming such an issue that our colleagues at MDAR, the Mass Department of Ag Resources, noted that last year the public reports crashed their reporting website. So if you haven't seen spotted lanternfly en masse yet, I won't be shocked if you will very soon. Another one I wanted to just highlight, box tree moth, and just how, again, I interact with non-native insects in the work that I do. This is another relative newcomer in the last couple of years, primarily an issue right now on boxwoods out on Cape Cod and in Barnstable County in many communities, and their boxwoods are starting to look like this because of the defoliating caterpillars. And we do have a new county added to the list, Norfolk County. The community of Brookline, Massachusetts, found box tree moth last year as well. So it's still super important that folks report this insect or damage that they're seeing, because this is what the boxwood shrubs look like when they go unnoticed. Elm zigzag sawfly, I think in the introduction, I believe I saw at least one or two folks with an elm zigzag sawfly fed upon leaf as their background slide. And so this is, yes, also on my radar. Not that elm needed another insect pest or disease, but this has been found in a lot of communities in Massachusetts. And very quickly here, I just wanted to note, if you're not familiar with southern pine beetle yet, this is the one, well, so it's native to the southeastern United States, not native to Massachusetts. And the probably the biggest connection to climate change that I'll make in this brief presentation is with this beetle. So this bark beetle has been able, research has shown, to expand its range northward because of our warming winter temperatures, directly due to the influence of climate change. So we have not historically had southern pine beetle in Massachusetts, but our state and federal partners started trapping it around. I know Mass DCR got it in traps in 2015, and I believe the U.S. Forest Service may be a bit before that. And in 2023, we've seen our first outbreaks and tree mortality starting on Nantucket and Martha's Vineyard. And so this image here is from last year of some southern pine beetle killed trees on Martha's Vineyard. And so, of course, another example of a non-native insect that we're dealing with, and a tight association with climate change. Okay, so very quickly to jump into those resources. So I know that I shared with Jenica and that it might be added to the chat, and I'm not monitoring that right now, but all of these links that I go through should be shared with you in the chat. And I do hope that you'll use this resource. This is a freely available online Professional Insect and Mite Management Guide for Woody Plants that includes a lot of information about over 200 insect pests of trees and shrubs. Many of them are introduced or non-native, not all of them. Some of them are native pests that can be problematic on ornamental trees and shrubs or in our urban forests. I know in the word cloud someone mentioned emerald ash borer, and I haven't even talked about that or mentioned it, but that's in here. And of course, that's a really significant forest pest, but it's been impacting our urban forests and managed landscapes as well. But this is hopefully a very useful guide that's available that allows you to search by the different pests, by growing degree days, host plant, and gather more information about these insects, and really hopefully is providing helpful information to our professional stakeholders that are managing these pests on a daily basis. And so this just gives you another example of what you'll see when you visit that website. We also have, and again, just to make sure folks are familiar with our landscape nursery and urban forestry program, although there are other groups of us at Extension serving different commodity areas. Our website is ag.umass.edu/landscape. There you'll find fact sheets about invasive or introduced insects, as well as native pests that can outbreak or be problematic towards the health of trees and shrubs. We have different newsletters available, again, freely posted on that website. The landscape message is available throughout the growing season, as well as hort notes, and both of them are just filled with a lot of different topics, insects being a relatively small part of that if you look at the whole of those publications. And we're also on social media, so you can really ask to be on our emailing list. You can find us on Facebook. There's lots of different ways to connect with UMass Extension, and I hope that you will. Again, very quickly here, I'll just mention that some of the outreach we've done about invasive insects or introduced insects included these grant-supported webinars that we did over a period of a few years. The archived recordings of those are still available on our website. And again, these QR codes are showing up on each page, because if you scan that with your phone, you'll be able to save these websites to look at these when you have a moment. I want to mention that we have an invasive insect certification program, and this picture is from the class of 2019 when we were in person, although we have moved to a virtual format for this. And so participants see a variety of different lectures from folks dealing with invasive insects in the state and the region, and researchers that are learning about these new pests and developing biocontrol, for example, and that participants take a brief quiz, and if they receive a passing score, that they get a certification in invasive insect management at the end. So really trying to bolster the knowledge of our professional stakeholders. And then I believe this is the last resource I will share, and hopefully leave time for a brief question, is that Insect Examiner is available on our website. You can see that, yes, spongy moth is featured and some other introduced species as well, but I also have a couple videos about our incredible periodical cicadas that had their 17-year emergence last year. So check those out. And oh, I knew I forgot. Diagnostics lab and reporting. We can accept tree and shrub samples to look at insect pests that you think might be bothering a tree or shrub or causing declining health. We also look at diseases and other pests as well, and we've found state records, new species to the United States via that mechanism. So again, the Plant Diagnostics Lab is available for you, and our normal means of reporting through the Mass Department of Agricultural Resources for Massachusetts, as well as anywhere else in the U.S. You can look up your state plant health director and connect with them and report suspicious insects on trees and shrubs as well. Okay, so thank you so much. 15 minutes is not a lot of time for an extension person. I really appreciate it. And if I have time for a question or two, I'd be happy to answer them.
Thanks, Tawny. We do have a minute. I did not see any questions come in over chat. So maybe there are no questions.
I did see one comment. Someone said so many spotted lanternfly in Springfield last summer, and absolutely yes.
Yeah, we have been also dealing with lots of spotted lanternfly in New York, which is where I am based. So, there was a question, how do you coordinate with other extension programs in the Northeast?
Oh, that is a great question. And I will say that we do communicate, and I know that our diagnostic lab does a lot of regional communication in particular as well. And I would have sort of one-on-one chats with different extension folks regionally. A lot of them have retired that I'm used to working with, so there's been some changeover, but I'm meeting some of the new folks as well. And I would say that seasonally, most of the time, I'm working a lot with Blake and now with Escher, but also Russ Norton out on the Cape. So we're also very focused on what resources we have to help folks in the state of Massachusetts.
Great, thank you so much.
All right, thank you so much. I'll stop sharing my screen for the next presenter.
All right. We're now going to, right. We are going to move on to our final talk for this session, and it is Winslow. He is a commercial drone pilot and design researcher for Fable Forestry, and he's going to be showing off and talking to us about knotweed, making invasive species management easier to do. So I know he is joining us from balmy Maine, and that is not a background. That is the real deal. So Winslow, I will let you take it away.
Can everybody hear me okay? With a little thumbs up. So I'll make
We
sure it's
can
coming
hear
through.
you, we can see you, and we can see your
Yay.
presentation.
Oh, that's perfect. So, great to be all today. Thanks so much for welcoming me and welcoming our work at Fable Forestry, where we're really focused on human-centered design and ecological restoration. And I'm stoked to talk to you about how we're applying those principles in support of invasive species management. So I'm a commercial drone pilot. I'm out here actually today in Poland, Maine. Deb will be familiar with removing brown-tailed and doing that here again today, hence the outfit. And so, yeah, this is real deal ecological restoration work happening on either sides of a presentation and by the nature of technology. And thanks so much to things working and the wind blowing the right way. You can hear me and it's working. So yeah, I live in Freeport. I'm a design researcher and a farmer and a beekeeper, and I've got 3 little kids, and it's a wild time. So I just pulled this because Jenica had brought it up right at the beginning of the presentation, and I was like, "Oh my gosh, this is so relevant!" Because there's actually 3 things on this list that I'm going to talk to you about today. So I just wanted to highlight those. Browntail is like happening within the next hour. I'll be actively trimming browntail using drones here, which is way exciting. And I'm going to talk to you today about knotweed and Phragmites a little bit more about how we're approaching these things. I want to start by saying, though, that I am trained in the behavioral sciences. I spent a lot of time learning about how behavior works, and I'm seeing a lot of opportunities about how behavioral design can positively impact EVRR. And that's a major caveat to this presentation, right? I'm not a trained biologist, forester, or ecologist, but being a farmer and a design thinker, there's some neat spillover. So thanks again for inviting me into this space where I'm very much in learning mode. So I want to also say, if you're curious about any of this work, We had a premiere last week at Patagonia where a 15-minute documentary about the last year of our work is summarized in 15 minutes. That video is available on our website at fableforestry.com. So a quick shameless plug to take a look at that if you're curious. So this is kind of the overview of the talk today. We're talking about EDRR, factors of human behavior, and then how we're leaving the age of information and entering into the age of context. And what does that mean for us in the invasive species space? So this is something you all know, right? The true value of early detection is at this earliest phase of work, and it's why speed matters. And speed is a big component of this work, speed of response. How much could we save if we acted faster? Trillions, quite a lot of money. And so why aren't we doing more? Everybody here is doing as much as they can. I think it's less about the folks who are on this call and following these conversations and more about the folks who are starting to learn, which is kind of where I am, right? So I'm just at the beginning of a journey. Early detection is a thing, perspective, because behaviorally speaking, this is loaded with a lot of assumptions, I think. So you've got early detection, and then you've got this word and, which perhaps completely capitalized to link the two. And then you've got rapid response. And of course, EDRR is different for alt access. So there's a whole pile of work there too. So please just put into the chat for a moment, what assumptions are we making when we say early detection? I'd love to get a sense of what people think when they say or hear early detection. And Jenik or someone else on the call, maybe you could read out a couple or announce them because I can't see everything on this small screen. Bethany says, looking for the species.
Yep. See what they're looking for.
Yeah.
Recognition of a problem and sharing, widespread searching, active observation reporting. Oh, it's going too fast.
Yeah. So we all have these gut level impressions of what that means. And it'll be interesting to look back to see like how similar are they? How different are they? This is a pretty robust phrase, right? And something that we kind of like hang our hats on in terms of like, hey, this is how we do the work. I think we should be paying a little bit more attention to what these words mean and how we're turning them from a phrase and into a culture. And school systems do this all the time with value systems, and I'm happy to talk about that work too. I see David's there too, that it's early, but at first find may be too late if you missed it for years. Totally accurate. All right. So same thing here for and. What assumptions are we making here?
Also,
Again,
doing
I'm
both
so
things at the
curious.
same times, that we do both things at once. Rapid response is linked to detection,
Funding.
funding.
Great. Yeah. Actually do something. Right on, Deb. Okay. Last one I'm going to ask you to do. Rapid response. What are these? Mark says it's more efficient. I can only see one line at a time. So forgive me if they go too fast.
That you'll do work if you find it early, takes place at a stage for eradication, remove it immediately, action right away, effective strategies, response immediately.
It'd be really fun for me to nerd out and go through this list. I'd love to talk with each of us thinks these mean. Of course, we have a global understanding that everything's going to be generally the same. It's going to be different based on community perception of simplicity, and I'm going to get to that in a second. So I think one of the first problems that I want to talk about is, and this is again where I nerd out, is even if you give a group of people information about what Phragmites looks like, how likely are you to expect robust early detection? And this is the world of heuristics. These are the mental shortcuts that we make to make sense of a complex world. And there's an entire body of literature out there about satisficing, which I really recommend if you're keen. So even if we're giving people information, there's this assumption, which is erroneous, that it's going to change your attitude or behaviors. Typically, giving people information does very little to drive action. These heuristics have an outside role in coordinating invasive species management from an outsider's perspective. And I think that the other thing about the inefficiencies that I'm trying to see is that I try to get a better handle on is the more disconnected the mapping is from mitigation efforts. So I'm thinking about mapping as, the reflection of early detection. I don't know what else it would really be other than noting it, but you have to notate it somewhere, right? So it has to live somewhere. This data has to live somewhere. And then the mitigation or the remediation, the longer those two are disconnected, the more effort there's going to be required because we're waiting longer. And has some more to do with the literature on cognitive load. But if we are in a race for time, which is what the invasion curve suggests we are, then cumbersome workflows are a losing strategy for change. And so this all means that we really should be digging into the science of human behavior. This is what I studied for a long time, what I call graduate school. But it is something that I think that you should be paying attention to if you're curious about how behavior works, because it's a pretty straightforward recipe that a lot of folks get wrong, even if they've seen it before. And so please ping me in if you want to talk about this. But this is about momentary behavior, not sustained behavior. So for behavior happens, I'll go back to this one. Behavior happens when you have sufficient motivation, sufficient ability, and a occur at time in the same moment. So motivation, we know, can swing from high to low. It's got a mercurial tendency, and it's influenced by sleep, caffeine, traffic, relationships. Like all these things influence motivation. Then you also have ability. This is really perceived ability, termed in other ways. How easy does this seem to do? And there are several subconstructs of perceived simplicity, like time, money, physical effort, brain cycles, back to cognitive load, and so on. Then there's this thing called the action line. And the action line suggests that above this line, behaviors occurs. Below this line, behaviors do not occur. So this is just for behavior activation, not sustained action over time. Okay, so let's do an example. So, hey, Jenica, will you donate $1 to the NE RISC when I ask you?
Absolutely.
Okay, Jenica says yes, because this seems easy enough to do. She's highly motivated. When I ask her, she says yes. And I'll ask myself for this one. Willow, will you donate 10 grand to the same organization? So note that I'm not sure, probably not. 10 grand's a big ask. Same, right? But the ability changes. So even if the prompt and the motivation are the same, all of a sudden the behavior does not occur because that is no longer easy enough for me to do. This is very important, right? It means that if things seem easy enough to do and we provide a prompt, if motivation is at a certain threshold, then behaviors will rely. And this is a critically important functional explanation of how behavior works. So back to what assumptions are we making? I wanted to fill this out a little bit more. Early detection and rapid response, right? It does this, it says this, it's in this. These three have to happen for every single step of this chain. So that means that at a minimum, you have 9 preconditions to complete early detection and rapid response. But that's just in one moment for one person, and everybody's perceptions are difficult and different. Even if something seems easy enough to do for you, designing it for somebody else is tricky. And that's where user experience and user research and a lot of researchy things come into play. So what do we do? So I'll tell you what we're doing. We're trying to really take a page out of that book of human behavior and make nature intelligence easier to do, make nature intelligence easier to capture. And we're doing it with these buttons. So we know this image. Folks say knotweed is everywhere. It's actually not. And I'll show this to you in a moment about how we're tracking this. So of course that we have to call the program knotweed. It's a very tongue-in-cheek, not weeds, right? No more of those. And I'm a farmer, so I can, support this from a number of directions. All we are doing with this button is clicking it when we cone counter knotweed, and it is logging in observations of Japanese knotweed to my phone and to a Google Sheet. And in 21 days, I collected over 1,000 observations of Japanese knotweed. So this couldn't be easier to do. It's less effort than changing the volume of my, when I'm driving around. And these observations were done when I was just driving around, driving to work, driving to take the kids to school or the dog to the vet, right? So there's no extra effort for me to collect this data. And all the phone is doing is grabbing, all the button is doing is grabbing an observation of my phone's location and putting in this very high resolution map. So these observations are as accurate as my phone is, which is plenty good enough. Deborah says the data is based on is biased. Totally, which is why it shouldn't just be one person. We need a whole group of people. And I would say that, any tool in the hands of one person has plenty of biases. But sure, we totally need more people out there doing this kind of work. And if we're going to ask somebody to do it, then we need to think about the perception of simplicity. So, point taken. Um, just as of yesterday, I updated the data, and the records are now, I've almost at 8,000. It couldn't be easier to collect. And I've also started tracking Phragmites, right? So back to Deb's comment about corridors. Like, it's not hard to detect this stuff, but it's about how like, are we making the boat move faster? If this is the race against time, and if this is the race against time, we need to think about perceived simplicity. So what are we doing with this data, right? Well, one thing that I think is interesting is that we can create geofences around these areas, around these things, and then can activate a camera to give us a better sense of real-time observation. So we're thinking that this could automate a Go 360 imagery camera, and then it's collected just on the cloud, and then when somebody through a geofence, a camera is triggered, and then you get street view imagery without even having to think about it or turn it on. So this is something else we're thinking about and cooking on. And what does this look like in practice? It means there's an easier way now to log nature intelligence. Municipalities are using these buttons to track events that can support rescue and recovery. It's not just invasive species, but that's where we started. We can use these to plan vegetation management and reduce wildfire risk, planning some prescribed burns. Citizen science could log nature intelligence that affects their commute. Research professionals can be using these buttons to ground truth satellite imageries. Parks and Recs folks can get a handle on trails data at the pace of recreation. Land stewards around the world can stash their phones. You don't need a phone to do this. You don't need to log in because you already decided what you're collecting data on. I see a question that I'll come back to about how can you connect this data to EdMaps or IMAP. Happy to talk about it at the end. The answer is yes, in short. And we can introduce budding citizen scientists to the natural world in a way that connects them to their phone, which I think is something that everybody wants. And perhaps these citizen scientists can be the ones to help us tackle kudzu. So some takeaways here. Early detection and rapid response, behaviorally, this is an aspiration. I think we think a lot about this as I'm learning about it as the gold standard. And even if it is the gold standard, I think it still deserves some unpacking. Is there an undo button if somebody gets button happy? Yes, we can talk about that. The buttons each have 3 actions, and we're making one of them a Command Z. So yes, we can talk about that. The other thing is, I think that it's critical to realize EDRR aspirations. We need to perceive simplicity. This is a critically important element of behavior design, and it is so often overlooked. Stop relying on motivation for short and long-term change. It's too slippery. It's just unreliable. And then the last thing is embodied AIs here. Tools have to be useful, usable, and delightful, or they don't belong in the toolbox. And so I have a tool with me here today that I wanted to share with you. This is Fido, and Fido can really do some pretty amazing things. Fido can dance. Fido can help with search and rescue. And how would you use Fido? If you were out in the field like I am today, this is a very inexpensive, approachable tool. And it's going to become as common as cell phones in the future as we get into the world of embodied AI. It's just the beginning. So I'll leave it there. And I'm happy to answer any other questions that you might have. Here's one of the ways that we're thinking about using embodied AI here in the farm work. So happy to connect further. And thanks so much for your time.
Thanks, Winslow. Very cool on how simple it can be to simply press a button and record information. We did get some questions, and you were doing great at trying to answer them as you went along. Very impressive. One is, this seems really great for community science, but I've struggled with phone-based data, GPS tools in areas where many people don't have cell phone or cell coverage. Is there a physical hardware option? Also, is it easy to correct accidental button presses, which you've already discussed? But
yeah. So the last question first. correcting accidental button presses. Each button that we have has 3 features. So you can do a press, a double press, or press and hold. And we're thinking of the press and hold as a Command Z. So if you think you saw knotweed and you're like, oh shoot, that wasn't knotweed, you can undo it. And then to the point of access to GPS, we thought a lot about this. We're working on converting those maps over to a task management sort of like user interface. So it's great to collect the data, but then what do you actually go and do with that? Can you parse that? Can you send something to somebody? Can you make a bid request? Like there's a lot more that we're going to be doing with that data that's not out quite yet. But we're working with a NASA scientist who's GIS trained and a buddy of mine to build out that platform. So go to knotweed.com if you want to get a better sense of what that is and what that's becoming. With regards to connectivity, I mean that's a huge limiting factor. I think that's going to be addressable with technology over time. We just have access to another $30,000 grant through MTI, Maine Technology Institute. So we're going to be trying what's Elon Musk's thing called? The satellite thing, satellite internet. Anyway, we're going to be practicing with that to see if that can't get us some connectivity in these regions. And also Starlink. Thanks for people in the chat. Yeah, we're going to be practicing with Starlink. And then also turning satellite data on your phone, and that might come at a cost, might be another way. Then there's also like offline logging of these things anyway, and then everything just bumps back up to the cloud when you come back into connectivity. So it's not a lot of data to store. Did I answer all the questions from that?
Yes. And
Matt?
I think one more quick one. If you are monitoring multiple species, how do you switch from one to the next?
It's so straightforward. Well, there's several ways you could do it. You could have more than one button. First of all, I have a panel of a couple of buttons, and you could just have them dedicated. You could also, have a button press type for different species. And so you could have a double press is for one species, a single press is for another, and then you still have your Command Z option. Another thing that I found is like encoding the density is really fast with the single button press. And so what you would do if you wanted to use just one button to capture multiple species is you just change what you're tracking that day, right? So when you set out to go do something, it'd be like, oh, okay, I'm tracking Phragmites today. And then you just make a quick drop down selection and then you're tracking something else. It's really straightforward.
Great. Well, that's all the time we have today, but I want to thank you for joining us, and good luck with the work that you're doing after this. Have a great
Thank you.
day.
Appreciate it.
All right. We are now going to switch to our next session, and there's no break in betweens, but thankfully you guys get to keep me as your moderator, so there's going to be no issues here. We're going to start our new session with the new Northeast RISC tools context and demonstration. Our first presentation is a duo, Matt and Thomas. They're both doctoral students at University of Massachusetts Amherst. And they're going to be talking to you about a new tool, Climate Smart Plant Selection Tool. So, Thomas and Matt, take it away.
Yeah, thank you so much for having us. Thomas and I are excited to be here to talk a bit about the new tool coming out of the Northeast RISC called Climate Smart Gardening, Plants for Remote Climate Adaptation. And we're going to share a link to this tool towards the end of the session today. Fran will explain why a little later. Yes, I'm Matt. I'm a PhD candidate at UMass Amherst, and Thomas will introduce himself a little further on. So I want to acknowledge that I did not do all this work alone, so I'd like to introduce all of the co-authors, including Thomas and I, behind the work that led to the creation of this tool here, so you can see them all listed. Some of them are some familiar faces. And we're excited to introduce you all to this tool. It accompanies our recent research to practice paper, which was called Climate Smart Gardening 2.0, Plants to Promote Climate Adaptation. And the goal of this tool is to really help you create lists of candidate climate smart native species for your own planting projects within our region. So a brief outline of how this is going to go. I'm going to go through some background on native gardening, how climate change can affect gardening, how we created the data set that went into our tool, and then I'm going to hand it over to Thomas, who's going to give us a demo on how you can actually use these lists to design your own climate smart gardens. So we know that a garden filled with native plants provides countless benefits compared to a non-native garden. Native plants support a greater diversity of native wildlife, and they also have less risk of invasion, as native plants are less likely to escape and become established in the landscape, subsequently having negative impacts like non-native species do. And really, native species are part of the solution to reducing plant invasions and planting those native species in their place. But despite these benefits, the ornamental plant trade is mostly made up of non-native species, which have detrimental impacts on our environment, and this serves as a barrier to consumers interested in planting native. It can be difficult to understand what native species they should be planting, and also which native plants are actually available for sale. Another barrier is climate change. We know that climate change is happening really fast, and in less than 100 years, the climate in Massachusetts, for example, is expected to shift the equivalent of about 400 to 800 miles south. So in response to this, plants will need to move great distances to track their preferred climate, which studies show they have not been able to do fast enough on their own. In fact, one study shows that native plants are being found to be spreading at a rate 20 times slower than the pace of climate change on their own. And these changes are already noticeable in the last decade, as shown by these shifting hardiness zones from the 1990s to today and projected to mid-century. So plant hardiness zones, if you're not familiar with them, are based on minimum winter temperatures, and they're an estimate used by gardeners to determine what can grow at a given location. So we can see that since the 1990s, hardiness zones have shifted about half a zone, corresponding to a 5-degree increase in minimum winter temperature. And by 2050, another half hardiness zone shift is expected. And these changing conditions are therefore also changing what species can survive in our gardens throughout the region. So therefore, gardeners will need to consider what species will persist in their area as climate continues to change. And this is where what we call climate smart gardening comes into play. So planting for present and future conditions using native and near native species adapted to both current and future hardiness zones. So I'm going to break down and expand on these terms a bit later, but for now, these are some definitions of how species are classified in our tool. We define persistent species as species that are suitable for both current and future hardiness zones in a given state. Native species are species historically found growing without human intervention in a given state. Near native species are species that are not native to a given state, but are native to a nearby state with a shared level 3 ecoregion. And the following slides are going to be hypothetical examples from the perspective of a gardener in Massachusetts to better explain these concepts. So this map shows areas of environmental suitability, which is basically the range of USDA hardiness zones that the plant species can tolerate of a plant being considered for a garden. So you can see that the areas of current suitability are shown on the map in blue, the future in yellow, and the overlap, so where conditions will persist, is in green. You can see the historic range of the species, which is the little picture of the plants in orange, is native to Massachusetts, and it falls within this green area of persistent conditions under future climate change. So we would classify this species as a persistent native, and it would be a species we'd advocate for planting in gardens in Massachusetts. But we know that plant communities don't often follow political boundaries, and this is where what are called USDA ecoregions can help us determine what species are okay to plant across state lines. So these ecoregions are a way of identifying areas of ecological similarity. So the black outline you see on the map there to the coast of New England represents areas which fall within the northeastern coastal zone ecoregion. And areas within that same ecoregion would be expected to have similar geology, landforms, soils, vegetation, climate, land use, wildlife, and hydrology. So you would expect that there would be similar plant communities and a shared evolutionary history across states which overlap the same ecoregion, and plants within them to be safe to plant if these environmental conditions persist across state lines. So for context, this is what the level 3 ecoregions look like at a national scale. So the one I was just talking about, you can see pointed at with this black arrow here on the right. And hopefully this gives you an idea of the size of these ecoregions when we're making use of them in our resource. So we only include near native species on the state list generated from our tool if the focal state shares at least one level 3 ecoregion with a state in which the species is native. So as an example, let's say we're interested in understanding whether this purple plant species you can see in Connecticut is safe to plant in Massachusetts. We know that its historic range is in Connecticut, but we can see that it falls within that level 3 ecoregion shared with Massachusetts that I explored earlier. And we can see that also the areas of suitability for the species are expected to persist within Massachusetts under future climate conditions. So therefore, this species is a near native species in Massachusetts. And by planting these near native species, as shown here by the little dotted out pink or purple plant, you can actually help facilitate their movement, tracking suitable habitat poleward in response to warming conditions. So as we know, the pace of climate change is much faster than native species will be able to move on their own. And because this movement is occurring within states of a shared ecoregion, the geographic distance the species is moving is not too great, which reduces the risk of invasive behaviors while promoting climate adaptation. So to summarize what I've gone over so far, the problems that people encounter when they're trying to plant native gardens include that they don't actually know what native species to plant in their area. It's hard to know what native species are actually available in the ornamental plant trade. And also climate change is altering what species will persist in an area. So our new tool seeks to address these problems by allowing users to create customized lists of climate-smart native and near-native plants that are expected to persist under future climate conditions in their area. This is just a screenshot of what the tool looks like, and when I hand it over to Thomas, he'll go into that in more detail, a brief preview. So the data underlying this new tool was created by surveying 339 nurseries in 15 states in the Mid-Atlantic and Northeast US for native species currently for sale. So you can see a map of the nurseries that we surveyed their inventories from on the right. And you can see an example from a nursery in Pennsylvania on the left showing a couple native species that we pulled out from their catalog. So through this process, we identified 1,472 species native to the lower 48, so a lower 48 scale. And we started with what's offered for sale in nurseries in our region to ensure that what we're actually recommending is commercially available somewhere and to address this common problem encountered by users of other native plant lists. We then standardized taxonomy to the World Flora Online taxonomic backbone to account for the fact that the scientific names are changing all the time and different names can be used to mean the same species from different catalogs. We then appended relevant growth, aesthetic, and ecological information for each species to allow any user to filter for their specific gardening project or use. So you can see the sources where all that information came from in the column on the right side of the slide, and the states each species is native to was appended from the World Checklist of Vascular Plants. And then finally, we also flagged aggressive or weedy species based off of descriptions from the Missouri Botanical Gardens Plant Finder tool. And we include these for the consumer to note, but it does not necessarily, just because it's described as aggressive or weedy, but also native, it may still be desirable in some cases as a ground cover or otherwise, and these are not descriptions of species as invasive. We then removed species that in which we found no optimal hardiness zone information for and filtered out rare, threatened, or endangered species from states where they're listed. So one example of this is Viola rotundifolia, which is endangered in Rhode Island and imperiled in Delaware. So that would not be a species we would recommend for planting in those states to avoid the wild collection of or the introduction of inappropriate genotypes near remaining wild populations. We also excluded any native species regulated by any state within our region. So one example of this is Robinia pseudoacacia, or black locust tree, which often behaves like an invasive species in our region. And even though it's native to the lower 48, and it can escape gardens and take over local ecosystems. So it's also something not recommended for planting in home gardens. We then identified those climate-smart native species that I introduced earlier. So we investigated if, for each species, if optimal hardiness zones persist in each state by mid-century under worst-case future climate conditions for each species. So a climate persister can survive current and future conditions within a state. So an example in Massachusetts, this would be a species which can persist despite the loss of hardiness zones 5 and 6 in the state by mid-century. And near native species were removed if a species was native to a state which did not include a shared level 3 ecoregion. So, as I explained before, a species native to only Connecticut and therefore near native to Massachusetts would be included because they share that northeastern coastal zone ecoregion. But a species native to only Virginia would not, because Virginia and Massachusetts don't have a shared level 3 ecoregion. So some quick examples of how we classified species in our tool. Relative to a gardener in Massachusetts, but all of these concepts were applied to any state included in the tool. So for example, American holly, Ilex opaca, is native to Massachusetts. It has an optimal hardiness zone of 5 to 9, and these hardiness zones are present currently and predicted to persist under future climate conditions. So we classify it as a persistent native species, and we encourage its planting by home gardeners in our tool. Rhododendron arborescens is not native to Massachusetts, but it is native to nearby Pennsylvania, which shares the northeastern highlands ecoregion with Massachusetts. And we know that its optimal hardiness zone range will persist under current and future climate conditions within Massachusetts. So therefore, this species is a near native species and a good candidate to be planted by home gardeners in Massachusetts. And conversely, fire cherry or Prunus pennsylvanica, we know this species is native to Massachusetts. It can survive under current hardiness zones in the state, but by mid-century, its predicted 2 to 6 optimal hardiness zone will be lost in the state, as the lowest zone in Massachusetts is predicted by mid-century to be around 7. So this is a species gardeners would not want to plant, as it won't persist, and we categorize it as a native loss. Finally, all of our lists and data that's included in the tool were reviewed by botanical experts, maybe even some of you, to filter out species that could be problematic in their region. So we gathered feedback through 2 different workshops with different versions of these lists, and also had separate individual reviews from 13 botanical, ecological, and horticultural experts across our region. So overall, the 15 states included in our tool contain between 539 to 770 native and near native species, which are commercially available and predicted to persist under future climate conditions throughout the Northeast. And now I'm going to hand it over to Thomas to give us a brief overview of the tool. Thank you.
Thanks so much, Matt, and thank you, everybody. My name is Thomas Neufer. I'm a PhD candidate at UMass Amherst in Dr. Bethany Bradley's lab and a member of the Northeast Risk leadership team as well. So like Matt said, I'm going to give a tool walkthrough. So I'm going to share my screen real quick to walk you all through how to use this application. This is going to be quick and dirty because I have just a couple minutes, so pardon me for going through this fast. I will also we'll be sending out a recording of a tool walkthrough and summary for this and posting it on the website coming up soon. So that should give you the chance to spend a little bit more time with these instructions.
Thomas.
So the web version of this tool is hosted on this website, climatesmartnativeplants.org, which I believe has been linked in the chat. We also are calling this CSNAP. It's sort of a sister website to the Northeast Risk website, in some ways, a place to host current and future tools for climate smart gardening. And on this homepage, you'll find a whole bunch of information about the website, about why to use native plants, why to care about climate change. We've heard a bunch about that today, so I'm going to skip past it and get us into how to use the tools. But I also just want to bring to your attention that there are some information resources here and some other tools linked, as well as a contact us form. So when we scroll down on this site, and I'm hoping folks can see my slides okay, and will let me know if they can't, or my screen. I'm just going to double check the chat and make sure everything's working. Okay, great. We scroll down and the Climate Smart Plant Selection tool is on the left here. This is where we're going to focus. Both of these tools are still in development. So we may expect some changes to continue to be made, or as Jenica mentioned in the chat, some server pressure if everybody's on this at once. So hopefully this will load okay for everyone. So when you come to this tool and from the home page. You have a little information box about how to use the tool, which I'm going to talk through, as well as some links for resources. This came up in the chat about where you can actually buy native plants. To get into how to use it, we start with this box on the left with filtering options. So as Matt mentioned, this tool is based on these state lists. So you're going to pick the state that you're in. I'm in Massachusetts, so I'm going to select that here. And it's going to provide me the full state list of persistent plants that we created in Massachusetts. Here, there's 590 plants found. And I'm just going to zoom in a little bit to make this easier to see. Now we have two options to sort of customize this plant list. We have these filter preferences here, and those filter preferences are going to actually reduce the number of rows that we see, the number of species. So let's say that for my garden, I only want to plant annuals, perennial herbs, grasses, and biennial herbs. I don't want any vines, shrubs, trees, or ferns. So as I've selected those filter preferences, my number of species has gone down to 380, filtering out anything that doesn't meet those growth habit. We also have the opportunity here, if you're only interested in those persistent native species or the persistent near native species, you could filter by that. I want to see both, so I'm going to leave that unchecked. You can also choose based on your sun level. So I'm going to choose full sun and part shade for my garden. And similarly, you can filter based on moisture level for your site, but I'm going to leave that blank as well. So we've reduced our list down to 364 plants. Now for our sorting preferences, these do two things. They determine what columns you're actually going to see in the data set. So right now, and I'm sorry, I'm kind of zoomed out a bit. If I scroll over on this interactive data table, I've just got these sort of filtering characteristics, our hardiness zones, the plant species name, growth habit, climate status, sun level, moisture level. And each of these things have a little tooltip, so you can hover over the column and get some information about what data are included there. So the sorting preferences additionally add columns to the data set. So if I'm interested in what wildlife services they provide and I check that box, the data set is going to reload. And now for each of these same number of species, I'll be able to see a data column about wildlife services if that data is available. The other thing that it does is it's going to reorder the rows of the data set based on which one best fits your characteristics. So let's say that I don't want those potentially garden aggressive species that Matt mentioned. I'm going to choose only species that aren't garden aggressive. I want them to be showy. And I'm really interested in my garden in supporting butterflies. So I'm going to choose butterflies as pollinators and butterflies as larval host species under my pollinators criteria here. And we've got these other characteristics about foliage, height, flower color, bloom period, hardiness zone, which is especially useful if you're like in a state like Maine, where there are maybe a lot of hardiness zones and you want to make sure that the species that you're seeing are suitable for your current hardiness zone. So as I've chosen those sorting preferences, it hasn't changed the number of species in the data set, but we've populated this match score column. And you can think of that as like how many of your criteria are met. So species that have 100 match score, they support butterflies, they are showy, they're not garden aggressive, and they have some wildlife services data. And all of these columns have appeared on my sort of spreadsheet here. So you can't sort of see the full pollinator column, but butterflies are going to be somewhere in all of these. They're all showy and they're not garden aggressive. And those are appearing at the top of the list. As I scroll down a little bit further past these, you can find species that aren't quite as good of a match. So some of these with a match score of 50%, you see some of them are garden aggressive. They're not showy or they don't have data on showiness or pollinators. And so that's why they're not coming up as quite as good of a match. And we've included that as an option rather than just filtering out those species entirely because we don't have data for every species, for every horticultural characteristic. So we don't want to restrict the lists too much, especially if people may be choosing a lot of preferences and some that may like conflict with each other. So this lets you, still have some species on your list in case you're flexible about some of these preferences. So we can use all these sort of things to come up with a plant list that we really like. We can sort this differently. So right now it's sorted by match score and then alphabetically by scientific name within there. But if we wanted to sort by something else, we can click on the name of any column and it's going to resort based on that column. So you can see all the full sun plants all together. A couple other features I'll point out quickly. We have this search function. The search function only searches displayed columns. So right now, because I have pollinators present on the data sheet, I can search beetles, and it's going to show all of the species that have beetles listed in pollinators. But if I had unchecked our pollinators there so that that column was no longer displayed, and I search beetles, nothing comes up because that column is not showing in the data set. So a column has to be visible in order to be searchable. Now, when you've got your species list that you're really happy with, that has all the information that you want on it and is filtered just as you like for your state, you have a few options to download it here. You can choose a CSV, an Excel spreadsheet, or a PDF. I like the PDF. It's really easy to print this out and just take this to your garden store as a shopping list. However, if you've chosen a bunch of columns or really wide columns, it's going to be potentially a little bit difficult to print in a visible size, so you might want to choose one of the spreadsheet formats. Speaking of shopping, I'll just bring your attention again to we have this links to lists of sources of native plants, some vendor directories and nursery directories. We don't maintain these lists. Obviously, we don't maintain the nursery inventories, but these are going to be some resources for how to actually find and buy these species in your area or online, so you can check those out. I've covered most of the sort of main features of the tool, and I'll just, as one more note, mention down here at the bottom, we have some funding acknowledgements, a recommended citation, and I especially want to give a shout out to Kabira Singh, who's not here today, but who drove a lot of the development of the user interface for this web tool. And finally, I'll mention that this tool is also mobile compatible, so you can use it on your cell phone or your Kindle Fire or whatever it is that people are using to access the internet these days. And as mentioned, it's in development. It's got a limited server capacity. So if you find that it's not loading correctly for you when you go to check it out, be patient, give it a refresh, and please feel free to use that contact us form to let us know if there's any feedback or changes that you'd like to see. And we'll also have a chance after this for a question and answer about this tool and the next tool, and a little bit of a chance for you to try them out yourself and provide some feedback. So I've gone a little over time. I'll stop there and hand it over to Bethany to tell you about the next tool. Thanks, everyone.
Thanks, Thomas and Matt. I'm going to pass it over to Bethany, who is a professor at the University of Massachusetts Amherst, and she's going to present on an invasive plant regulation tool.
Thanks, Matt. So yeah, we're continuing the tool fun that we've been having with RISC over the last 9 months or something like that. This one is much more aligned on the invasive species side. So we started a new website last summer called risktools.org. And the tool that we've got set up now on that is on visualizing state invasive plant regulations. And I have a couple of slides to start with on this too, just as the framing of like why we want to visualize state invasive plant regulations. So I'm sure preaching to the choir here, and that everybody in the audience knows that most invasive plants are introduced as ornamentals. So if we look across the landscape of the Northeast, some of these ones that we continue to manage, like bittersweet and purple loosestrife, introduced as garden ornamentals through the horticulture trade. And in fact, if we look at all of the different invasive plants across the US, more than 50%, so about 60% of them were intentionally introduced, and the vast majority of those intentional introductions are as ornamentals. So basically more than half of those plants. So as a result of this known pathway of invasive plant introduction, there are regulations at the state level across the US to try to prohibit that pathway of introduction so that we reduce the numbers of invasive plants. Unfortunately, we've got a problem with the regulations that are used to prohibit the sale of those invasive plants. And that problem is that there's a high level of inconsistency between neighboring states and across regions with similar ecosystems and similar susceptibility to invasive plants. This is a map from a paper from a couple of years ago by Eve Bury, Emily Fusco, and others that looks at the numbers represented in the colors here are the number of species that are present in that state that are not regulated by that state, but are regulated by one of the neighboring states. So you can see on here that many of the states we have 40, 50 more species of plants where the focal state is not regulating a species, but the neighboring state, one or more neighboring states, are saying that that is an invasive species. And if you compare two neighboring states across all of the continental US, the average overlap in regulated invasive plants between those neighboring states is only 17%. Right? We would expect that if we were talking, I'm in Massachusetts, if I wanted to look at the overlap between Massachusetts and Connecticut, I would expect that number to be closer to like 90% or even higher. And in fact, even across the Northeast, that number is kind of shockingly low. And so as a result, what that does is it creates this sort of patchwork of regulation that means that most invasive plants continue to be for sale. So this is another paper by Eve Bury from a couple of years ago showing that 61% of over 1,000 plants surveyed are remaining for sale at one or more vendors across the US. So the lack of consistent regulation means that it's confusing for vendors, it's confusing for homeowners, for home gardeners to try to figure out what is actually invasive here. And so one solution to this potentially is the need for more consistent invasive plant regulations across state borders. And if you were here yesterday, you heard Sarah Boyce talk a little bit about all of the steps, many of the steps that are involved in getting to the point of regulation. So this isn't necessarily an easy process, but one piece of information that we hope can help with that is just being able to see what species are actually being regulated by our neighbors and what that looks like. And so that's where this tool, another tool, comes in. So this is on the risktools.org website, regulatory visualization, and we can drop a link for that in the chat too. These are, this is a fairly straightforward tool. So if I want to look at a particular state, so let's try New York, our neighbors. Then New York, all of the states that are regulated in New York, and New York has two levels of regulation. One is prohibited plants and one is regulated plants. Have this listed in reverse alphabetical order, but you can look through this whole list. You can scan to the next ones, or you can also download it if you are like me and prefer to look through spreadsheets in Excel or something that isn't a web tool. So if you're interested in one particular neighboring state, you can see what the species are that are being regulated, or you could also focus on a particular species. So I'm just going to go with barberry and see what all of the states are where that species is being regulated across US states. You can also download that to grab that information. And we also have this regulation map over here, which just gives a hopefully helpful visualization for the different states where barberry is currently regulated, so that you can zoom out, and see where things are regulated. So for example, like this map might be helpful if you're in Connecticut or Pennsylvania or something and just trying to illustrate, hey, this species is regulated by all of our surrounding states. Maybe we should think about regulating it as well. Up at the top of this tool, there are two links. So one is the source of these data, which is the National Plant Board website. So this is where we got this information from. There are a bunch of, the way that the information started is a bunch of PDFs that are all searchable. So here's the Alabama one, for example, and we can see on here the list of Alabama noxious weeds. One thing that's worth pointing out here is, we spent a lot of time and students spent a lot of time pulling information out of each of those PDFs to make a database behind the scenes. But we are not perfect people, so that definitely might be some mistakes in there. If you see those, we really want to know about them so that we can fix them. Another thing that's relevant is that we are right now updating this database. Our goal is to try to update it about once a year in the summertime, which is when we academics have a little bit more space and staff to help out with stuff. So, for example, we don't yet have the updated Connecticut regulations on this web tool, but we'll hopefully get that and some of the other updates up this summer. And if you are a database lover like me, you can also access the full database from this link, which has information about where these data came from. This is the full database for all of the different states. I think it's sorted by Kansas right now, but anybody can access this and sort it as you like. And it also has some information about definitions where we've been able to find them about, for example, what that Alabama Class A, B, C noxious weeds actually mean in terms of definitions. Again, this is, I'm going to say it's a near final web tool. We're really excited to hear feedback on it, though, just like on the Climate Smart Native Plants tool, and hope that you'll poke around out there, let us know what works and what doesn't work so that we can improve it into the future. And that's it for the regulation tool. So I'll stop sharing so we have a couple minutes for questions on both of these tools.
All right. Thanks, Bethany, Matt, and Thomas. We're going to jump to questions, and let me pull up the nice sheet that all the moderators put together, so I don't have to dig in the chat. How much overlap was there between the list of climate-smart species for a particular state and the current lists of available plants from nurseries in that state? If I made a list today, for example, would my local nursery have a lot of the species, especially the ones not considered native?
Yeah, I can start on this one. So for nursery availability, we were working at the scale of the entire region. So if the species was present at least one of the nurseries within the entire region, it was included on the list. So we didn't actually verify if it was available like hyper locally, like to each individual state. But I would say for most cases, they're available at more than one nursery. So you wouldn't have too much of a problem finding them necessarily. But that is a future direction we'd want to go in, is like state by state verify availability, like at a smaller scale, I would say.
Yeah, and just one of the challenges with that is that the nursery stock is changing all the time, so nurseries come and go, their availability changes. We hope availability is increasing and expanding rather than that we're like losing native plant nurseries or species availability. But it is difficult to maintain a sort of live list in each state of where to buy exactly which species, especially with a lot of the small local native plant nurseries that don't necessarily have the kind of continuous online presence of some of the larger groups.
This is another question for the CSNAP tool. Does it also include ecoregion?
It does not, but ecoregion is used to help filter the species down for each state to make sure that they're adequate for planting in that state. But it does not filter by ecoregion at this time.
This is for you, Bethany, I believe. How did you discern between invasive lists and noxious lists?
Yeah, it's actually really challenging to find the definitions. That's why when you saw the definition of the regulatory processes, a lot of them say unknown because we haven't been able to find them yet, although we need to spend some more time trying to find it. The short answer to that is we've included everything that's available. So it should say if there is a difference in definitions between different plants, we see a lot of like ABCs or 1, 2, 3s kind of things. I don't know specifically how different states differentiate between invasive versus noxious. A lot of them seem to have all of that information together. So we're just reporting whatever the states are reporting.
And as a follow-up, are these all regulatory or advisory?
Some of them are regulatory, some of them are advisory. Yeah, so the looking up the definitions of them, I think, is an important piece on there. But our perspective on this is that if any state has put it on a regulatory advisory watch list, something like that, then they, in all likelihood, have identified that as an impactful invasive plant in their state, and is something that all of us should be aware of. In the Northeast, this is sort of an aside to this, but in the Northeast, we have gathered from a lot of the states. So this is courtesy of all of our invasive plant council representatives. We have a lot of the impact assessments that have been done for those species. And I know that in the Midwest too, they've been putting together a big effort to gather the actual behind the scenes impact assessments for all of these too. So depending on what the end goal is, whether it's to know specifically what's regulated and prohibited for sale, we should be able to see that through the definitions list, or if you're just looking for generally what species have been evaluated and identified as impactful, the larger list should give that and know that we have more information and can point to more information about the actual regulatory assessments.
Can you list what the regulatory level means?
It depends on the state what the regulatory level means. So this Gary, do you mean can we do that in the tool, or because we could do that, we could put it in the tool itself and have some link potentially to the behind the scenes regulation.
Yeah, I think that's what I mean is just have a way of maybe clicking on what it is and it will tell you what it means, or even just have it somewhere where you can, like at the top where it says regulatory level and has the question mark, maybe the question mark could go to that list of what those things mean. I don't know. I'm sure it's difficult because states use similar things for different reasons.
But I think that's possible, that we would basically like hyperlink each of them to something, either a definition sheet that we put together or one of the definition sheets. Matt's nodding because he's the one who actually like owns this spreadsheet. He's actually the one that you should email if you have any questions, even though he's graduating in 2 weeks, so his email's going to disappear soon.
Okay, I think that is all the questions that I see on my list. I know some of them were already answered in the chat. The last part of this is a discussion and tool practice, which I'm told that the three of you know or have it handled. So I don't know, am I turning it over to you, Matt? You shook your head, or you, Thomas?
Sure, I'll take it. I mean, this is really just a chance for, if you haven't already been doing this as we've been presenting, for those of you in the audience to pull up these tools, try interacting with them for your purpose. And if there's, anything that you want to share in the chat about your experience using them, we've had some great questions, but any other, notes about how you might use them, feedback about the tools. Yes, tell us if you break them, if the server goes down when all of you get online. But it's just a chance for you to play around with them a little bit and see what you think. And I guess I'll say, and maybe this is a question people can answer in the chat. Like, I'm curious about how those of you in the audience working in different contexts envision yourself using these, or who you might imagine sharing these tools with. Usage information is not one of the things we're collecting right now, so anything we can find out about how these are or might be used is really helpful. Somebody is saying that they're having a problem in Chrome with the page loading and then graying out. That is what happens when we get kind of a server overload. So if you give it a minute, it will probably fill in, or you may need to try refreshing it in a little bit of time. Sorry about that. This is kind of our first test for some of these, getting a bunch of people all online at once.
Yeah, I was having the same issue with what is this?
Yeah, maybe this is an opportunity to plug the Risk Minute Fund so to support some of the server costs of some of these tools. Allison, I see your question about similar tools for climate smart plant selection for non-Northeastern states. I'm not aware of a tool that does that outside of this region. There are definitely a lot of native plant selection tools. The sort of climate persistence piece of this, as far as I'm aware, is a little bit more unique for this sort of interactive tool. But if anybody is aware of something similar that exists in another region, definitely please drop a link in the chat. I'd be curious to see it. It would be great to have, to have more resources like this.
I have a question for you, Bethany, actually, while people are playing with the tool. Um, for the regulatory tool, what is the process of updating that as states update their regulation lists? Are you going to be checking
Yeah.
yearly to look, or are you relying on states to inform you, or?
So we have been using that National Plant Board website as our space to check on updates because they post updated PDFs. I mean, I did notice in going through that there were a couple of states that had updated more recently than the plant board had on it, but so there are a couple of spaces where we might miss things, partly because the states aren't updating to the National Plant Board and or because we mistyped something. Yeah, so, well, yeah, some states and other states are fast, Gary. See, like we've got Speedy Connecticut going in there of like 2026 stuff already out. We did though, we put New Jersey in there. We felt like we needed to represent New Jersey, also because Matt's from New Jersey, so he so the New Jersey ones are in there, but nothing else from late 2025 or early 2026 is in there. Our goal for this is actually to hire undergraduate students to intern with Risk or an undergraduate student each summer, and that part of their tasks would be to go through the regulatory assessments and update that underlying data sheet and the tool. So it would be probably each summer, but not more regularly than that.
I say that because I know that New York is currently looking into updating their regulations. So when that happens, I'll let you know.
Sounds good. You've got my number.
All right, we have 3 minutes left. I don't know if you are looking at the chat, but lots of praise for the tools and how invaluable they are, and that they'll be shared with a bunch of different people. But are there any other questions, or would you like to do anything else with the discussion or tool practice? If not, I'll begin shifting.
Thanks, everyone.
All right. So that ends our morning of the symposium. We're going to be breaking for lunch. I want to remind everyone to come back at 1 o'clock. We still have an afternoon with a lot of great presentations, including one from my colleagues at DEC about laurel wilt. So make sure to come check that out. Little plug. But there is another lunchtime poll. This is a different question from yesterday. So if you could please use the QR code, or I'm sure we can put the link again in the chat for those who can't use the QR code. Please fill that out over lunch, and we will see you back here at 1 o'clock. Thank you so much.
There we go. Welcome back, everybody, to the 2026 Northeast Risk Symposium. My name is Jenica Allen. I'm the director of the Northeast Risk and the chair of this year's symposium. If you haven't been able to join us yet throughout the symposium, welcome. We're glad you're here. If you have, thanks for coming back. We've got a good lineup for this afternoon. We have a presentation session right after this that is focused on emerging issues and more specifically emerging species in the Northeast. We'll take a short break after that presentation session and then come back for a session focused on breaking research that is relevant to invasive species and climate change. Some new researchers that you may not have connected with previously. After that, we will have the presentation of this year's Northeast Risk Impact Award, and we will finish up with some closing remarks by the last RISC co-founder, Tony Lynn Morelli. So we've been fortunate to have all of our RISC co-founders involved with this year's symposium. And so, for anybody who wasn't able to join us earlier in the day or yesterday, this is just a reminder, you got the audible that this session is being recorded. There's one presentation this afternoon that will not be recorded at the request of the presenter because it's kind of breaking research that hasn't yet been published. So you may hear just a notification that the recording has briefly stopped. Just don't be surprised by that. If you need any help finding transcription, the transcription button on Zoom, just let our team know. And please continue to the activity in the chat. It was flowing fast and furious this morning. And so we'll be saving those chats. Someone had asked about links that were shared in the chat. We'll be doing our best to pull some of those out of the chat and share those back with some of the summary materials after the symposium is concluded. So without further ado, I'm going to go ahead and stop sharing, and I am going to turn it over to Emma, one of our leadership team members, to host the next session.
All right. Thank you so much, Jenica. Thank you, everybody, for joining us. Our next session is our emerging issues session on some of the up and coming invasive species concerns in our region. Our first talk is going to be from Kelsey McLaughlin, who's a forest pathologist with the New York State Department of Environmental Conservation, and Liam Summers, who is also with the New York State Department of Environmental Conservation as an entomologist. They're going to be talking about the new kids on the block, laurel wilt and red bay ambrosia beetle in New York State. So take it away, Kelsey and Liam.
Good.
Looks great.
Perfect. All right. Thank you, Emma. My name is Liam Summers. I'm the forest entomologist.
And I'm Kelsey McLaughlin. I'm the forest pathologist.
And we work for New York State Department of Environmental Conservation at the Forest Health Research Lab. And today we're going to be talking about a new disease and its beetle vector that was recently detected in New York State. So that new disease is laurel wilt, which is a fungal vascular disease that prevents its host from moving water around its system, essentially clogging up its water vessels and drying it out and causing it to wilt. So the disease was first detected in Georgia in 2004 and the beetle 2 years prior in 2002. And since that detection, it has spread throughout the Southeast, from eastern Texas up to South Carolina and Kentucky, where it's responsible for killing hundreds of millions of trees in that range, most notably red bay, swamp bay, and avocado. Before it jumped about 4,000 miles up to North 400, excuse me. It jumped up 400 miles up to Northport, Long Island, when we detected it last summer. So it infects plants in the laurel family, and New York, that's going to be sassafras and spicebush. And this is not to be confused with plants that have laurel in the common name, like mountain laurel and sheep's laurel, cherry laurel, and so on. This is only going to be in Lauraceae. So the main way that it's vectored and it spreads to new forests is by the red bay ambrosia beetle. It is native to Asia and was likely introduced to the United States and infested wood packaging material, like a lot of our invasive wood-boring beetles. And in the South, they have overlapping generations, so they'll just be continuous throughout the year, and there's no major peaks in the population size throughout that year, where we believe that it has 2 generations in New York, one in the growing season and one overwintering. And it reproduces through partial parthenogenesis. So what that means is it only takes one adult female to start an entire new infestation. They can lay a haploid egg, which develops into an adult male. And that female will breed with its offspring and lay a bunch of female eggs, which starts a completely new infestation, all with the mother's genetic sequence. So fortunately for us in the north, this beetle isn't very cold tolerant. There's a study that was done in Mississippi in 2017 where they collected a few groups of these beetles from the summer generations, the winter generations, and then the artificially acclimatized group, which was made to kind of replicate what our temperatures look like in the Northeast. So you could see at the 10-minute interval, just exposed to negative 10 degrees Celsius, that killed off a lot of the population in the summer and the winter groups, but With the artificial Northeast group, it only killed off about 15%. But at the 24-hour interval at -10, it caused 100% mortality across the board in all of these groups. So for context, -10 degrees Celsius is about 14 degrees Fahrenheit, which is a temperature that we pretty regularly hit here in New York. This study wasn't taking into account thermal buffering, which is essentially the insulation that's provided by the tree. As the beetle bores into the sapwood, it's kind of insulated by all that thick bark and that wood. So it does need a couple hours of sustained temperature at these low temperatures to be able to penetrate the bark and cool down that system, ultimately causing mortality. And this beetle in particular, it does like to infest the lower part of the tree. So if there's a lot of snowpack, that just kind of adds another layer of insulation, which could be a problem. But fortunately, like I said, we do hit 14 degrees Fahrenheit fairly regularly, which is just a temperature that was hit a couple of times on Long Island this winter. It was a pretty cold winter. So we are expecting a good amount of beetle mortality, but that's something that we'll see this upcoming fall. Or excuse me, summer. And in that same study, they did some predictive modeling, looking at the native range of sassafras across the eastern United States. And it's a little difficult to see, but up in the Northeast, in the New England area, you can see there's some sassafras and going into Long Island, and then up in that southern tier area, which is like the elbow of New York that meets Pennsylvania. There's a good amount of sassafras sprinkled throughout there, even though this map doesn't really look like it. And on the left side, you have the temperature data that's overlaid the sassafras map from 1961 to 1990. So that's what it's typically looked like with our winter temperatures. You can see that it's kind of hitting that wall of high winter mortality. But what we expect it to look like in 2050 as our winters keep warming up is it's no longer being controlled by that low winter temperatures. So the beetle is able to proliferate and continue to infest sassafras and spicebush in our range. And I'll kick it over to Kelsey.
Yeah, so I just wanted to talk a little bit about kind of how we found this and how other states can keep an eye out for laurel wilt. And just starting off, kind of continuing from Liam's with lauraceae on Long Island. So sassafras, the main tree lauraceae we have, is much more well distributed in the south. But like Liam mentioned, we do have quite a bit on Long Island. And then spicebush doesn't have a ton of range data the same way sassafras does. So one of the main things we use is iNaturalist observations. So that center map is just showing for Long Island and parts of New York City the observations of sassafras and spicebush that we had available. So we have quite a bit of lauraceae on Long Island, and for a couple of years we've been getting reports of 6 spicebush and 6 sassafras on Long Island. But we were usually able to trace it to other things like Boschersphaeria canker, drought damage, things like that. So we were actually thinking about kind of putting together a sassafras and spicebush survey on Long Island just to see what was going on. And at the same time that we were doing that, Suffolk County Cornell Cooperative Extension was getting a call from this concerned citizen in Northport. This person had seen their sassafras tree wilt very, very suddenly. So Cornell Cooperative Extension contacted the Long Island Horticultural Research and Extension Center. And so Marjorie Daughtry and Nina Viscera were there taking the samples from this plant. When they cut into it, you could see that really dark ring in the sapwood. That's going to be one of the symptoms we talk about in a little bit. And so Marjorie took these samples, cultured them on PDA, and she said, holy cow, this is starting to look a lot like the laurel wilt fungus. As we mentioned, it was over 400 miles away at that point, so it wasn't really super on our radar. But this was later confirmed by the University of Florida and USDA APHIS to be laurel wilt. So that was happening, and then at the same time, Bartlett Tree Care Company was rearing out the red bay ambrosia beetle from infested bolts that they'd collected on Long Island. And so we had this brand new pathogen and this brand new pest in a new part of its range. And so our response at DEC was to kind of coordinate survey efforts and get some boots on the ground. So we were able to survey over 3,000 host plants across the state. The vast majority of the plants that we surveyed were asymptomatic, but within sort of that core area of Long Island around Northport, around that initial detection, we found just under 750 plants that were either wilting or dead. That's likely a slight overestimate due to those other things I mentioned that were causing sassafras and spicebush dieback, like drought and botryspharia. But it gave us sort of a starting point of how this disease might be already present in New York State. We also were able to get 50 public and partner reports, which was great. And we submitted 23 samples from 15 sites, which are represented by those red stars in this map. Those samples that were positive were only from 3 towns in Suffolk County. We have not found positive trees outside of Suffolk County. Also at this time, we have only found sassafras trees that are positive. It can infect spicebush. We know that from other states. But one of the other things that we've heard from other states is that it tends to sort of spill over into spicebush once the overstory trees have been sort of severely affected. So that might explain why we're not seeing a ton of spicebush damage yet. So if you want to look out for laurel wilt, I would encourage it if you have sassafras stands that you're kind of concerned about. The big symptoms to watch out for, the big one for sure is this dark streaking in the sapwood. You can see this in cross section, this sort of dark ring around the outside, or you can see it from the side if you cut just under the bark. If you cut too deep, you can sort of blow right past it and miss it. So you really want to get just under the bark, just under that cambium, and then that streaking should start to become apparent. What might clue you into needing to sample some branches is if you see trees like in the middle here, trees that are browned out and wilting in a very, very short period of time, usually just a matter of a few weeks. That photo on the bottom kind of shows the variation in color that you can have. So oftentimes it's described as looking like early fall color, and then the leaves fade to sort of an olive gray, and then they'll fade to a brown and start falling off the tree. The other thing, kind of like the most famous symptom of red bay ambrosia beetle and laurel wilt, are these frass tubes or frass noodles, some people call them. We only saw this on maybe 5 trees that we surveyed last year. The conditions need to be perfect. They're not permanent structures. They can be knocked off by wind or rain, but you might see these sort of small piles of sawdust in the bark cracks as evidence of that beetle activity. None of these, definitively say your tree has laurel wilt, but they might be an evidence that you use to sample and do some further testing. So if you do want to sample, the first thing I have on this slide is please contact your state's forest health agency. They're going to want to know, I promise you. They can also help connect you with a diagnostic lab or the best place to send that sample for testing. When you're collecting samples, the smaller branches have thinner bark, and that's easier to access that streaking where the fungus is located. So that's something our diagnosticians found out this year, is those smaller branches are just a lot easier to work with and test. If you don't have access to smaller branches, you can use a chisel or Ontario knife to access the vascular tissue on larger tree trunks, as shown in this top picture here. We recommend checking multiple places or branches from streaking because that streaking is often needed for a good culture sample. That dark area is where the fungus and the plant are kind of duking it out. So that's sort of the best place for a diagnostician to collect that tissue, to try to grow a culture or to run DNA testing. But don't peel all the bark off your sample. Don't get carried away. That'll make the sample dry out and be unusable. So kind of just like the bottom picture here, you just want to peel off enough to see if that streaking is there, and then leave the rest of the sample intact. The final tip we have for sampling is culture and PCR results may not always agree. PCR is sort of the DNA test for laurel wilt fungus. And this is common across multiple wilts that I work with. We use both tests for oak wilt, for example, because we found the same thing. So if you're really concerned, we recommend kind of doing both to sort of double check if the situation warrants it. And that's all we have. These resources on the right will take you to different links from DEC and Cornell. The last one here is actually a video that they put out pretty soon after we announced the detection. They gathered a bunch of Southern experts who'd been dealing with the disease for a long time. And so it was a really, really informative video. If you want to learn more, it's a great place to start. And just thank you to everybody who helped us with this. It was a huge effort and had lots of people involved, and it was really great to work with all these different folks. But yeah, happy to take any questions.
Sorry, I'm silly and was still muted. Anyway, thank you so much. It looks like we don't have too many questions in the chat at this point. We did have one person ask a little bit about winter temperatures in Maine and note that there are both species grow in Maine as well, but wondering if the winter temperatures there might help keep ambrosia beetles at bay. I'm not sure if you're able to comment on that at all.
I don't know much about the temperatures in Maine, but I mean, like I was saying, 14 degrees Fahrenheit has been shown to kill that beetle, but it does need sustained a temperature at that level at least, or lower, and theoretically that should kill 100% of that population, but there is a lot of like variables that go into that. So saying 100% anything is a little forward, but I would imagine Maine, being a little bit more north than New York, probably gets the similar temperatures. So I would think that yes, for now, yes, those winter temperatures will keep them at bay.
Great, thank you. We had another question about whether there are any preventative fungicides available for example, high-value trees.
So there have been fungicides that are advertised as preventative. Their efficacy has been questioned. It's really tricky to sort of get it distributed throughout the entire vascular system of the tree. And at this point, I think it's only really recommended for like very high value specimens and like arboretums or stuff like that, because it does need to be injected and it needs to be done repeatedly. So it can be quite expensive and kind of cost prohibitive.
Great, thank you. All right, I'm not seeing any more questions in the chat at this time. So if you have any more questions for Kelsey or Liam, please put them in there and hopefully they'll be able to take a look. And then in the meantime, I'll move us along to our next presenter. Next, we're going to hear from David Wong, who's an environmental analyst with the Massachusetts Department of Environmental Protection, to talk about recent invasive plants to Massachusetts freshwaters are tropical or subtropical species. And David, I can see your screen. It's not in presenting mode yet, but it looks like it's on its way.
Yes, I think I tried, it worked, but now I couldn't find the swamp. Let me see. Can you see my slide?
Yes, we can see your slide.
Yeah, why? I think that when I did the test the other day, I should be able to swipe the. But now I couldn't see that sign anymore.
Yeah, we're seeing presenter view right now. Maybe if you go to display settings at the top.
Yeah.
You might be able to. I think there's a setting in there about swapping presenter view and
yeah, that's why I couldn't see that. I don't know what's going on here. Okay. Now what?
Perfect. That looks great.
You can see it?
Yep, it looks good.
Okay, thank you. We try to find the laser. Sounds like the set is very different from. I want to find the laser point.
I think we can probably see. Can you move your mouse over your screen? We can often see that.
Yeah, can you see my mouse?
Yes, we can.
Okay, that's great. Sorry, guys. Probably like 30 seconds. Good afternoon, everybody. Thank you, Emma, and everybody all to help to organize this fabulous conference. Yeah, my talk is about recent invasive species in Massachusetts freshwaters. It turns out they all tropical and subtropical species. Oh, I couldn't move my slide. Oh, now it worked. So in Massachusetts, we have 27 larger watersheds. For example, here, 34 is the Connecticut River watershed. You go to the bottom right, that's the hard water drainage area, and 97 is the island drainage area. So among those, 27 watersheds, they are mainly for rivers, streams, lakes, pond, and coastal area, right? So, but for rivers in Massachusetts, there are over 8,000 river miles. I think 8,200 or something like that, and also over 3,000 lakes. In 2023, it's like 2.5 years ago, I summarized a lot of invasive species data for lakes and rivers in Massachusetts, and found that, well, among those 3,000 lakes, we have 701 lakes or ponds are infested by invasives, and also 140 two rivers or streams are with invasive species. So that's, in terms of the percentage, that's pretty high, about 20%. So that's a very high ratio for being infested by invasive species. But data are mainly from state agencies like conservation regulation and environmental protection, as well as some federal agencies and universities, and even some private consulting companies for working on freshwater invasive species. So among those, there are 15 document invasive plants. So usually, we know in aquatic system, we have emerged, floating, and submerged. For submerged, we have 9 invasives. This is a hydrilla, the curly leaf pondweed. This one is Eurasian water milfoil, and the variable milfoil. This is a farmwood. This is a parrot feather. This is a European naiad, and this is a South America waterweed. And this one on the top right is called swollen bladewood. And this species, they can eat tiny animals like zooplankton, Cecilia or some of the nauplius of those zooplankton. So it's very, very unique species. For the floating invasives, there are 4 documented species. It's a European water clover, and this is a yellow floating heart. This is a water hyacinth. And this one, probably one of the most famous in Massachusetts, is a water chestnut. For the emergent species, I think almost everybody knows they are the purple loosestrife and the phragmites. So the first one in the record in Massachusetts is 1831 in Cambridge, is the purple loosestrife. The second one is next to Cambridge, is in a pond in Arlington. It's a yellow floating heart. Actually, it's like a golf course pond. This was documented in around 1840s. It's the phragmites, and then the next one is water chestnut, the European water clover, and the last one here in the 1800 is the curly leaf pondweed, and then go to early 1910, is the European, the Eurasian water milfoil, and then is the farmwood, and the South American waterweed. That's in 1930s. Then the variable milfoil found in 1940s. Okay, this is the one, the European naiad, but it's in 1970s. Then number 12, the swollen bladewood, starts from 1990 almost to 2000, and the same for the water hyacinth. Number 14 is the a hydrilla in 2002 in Cape Cod. The last documented is the parrot feather in Jones River 2006. So this is the 15 invasive species, plants in freshwater in Massachusetts. Now it looks kind of messy, right? Let's go this way. So in 1620, we know the pilgrims came here with the Mayflower, right? That's 1620. So that 1776, this beautiful country was established, right? So the first one document 1831. So let's go this way, because one by one. The 6 species basically documented in the 1800. Okay, then the next 5 species is early 1900. So like 1910, 1930, 1930, 1940, 1960, or early 1970. But then from 1992 to like 2006, the 4 new documented freshwater species are the swollen bladewort, water hyacinth, hydrilla, and the parrot feather. So these are the 15 documented invasive plant species in freshwater in Massachusetts. Okay, so here is a map showing. Well, to give you an example how they distribute. Here, hydrilla is basically in 5 major watersheds. Start from Long Pond, Cape Cod. This is the Cape Cod watershed. And then also cover the other 4 watershed. One of them is the Connecticut River. The recent documentation is next here, but it's also in the Connecticut River watershed. Just an example. But if you look at the speed of kind of envision or documenting, you can say, in before 1990, early 1990s, average about 13 years, you'll see a new invasive species. But after that, from late 1990, about every less than 3 years, you'll see a new invasive species, like a plant, a new invasive plant. But also, I want to share with you is that look at this 15 invasive species. Okay, in the 1990s, only 2 of them, the firewort and the hydrilla, the South American water grass, they are waterweed. They are the original from tropical subtropical area. But for example, like the South America waterweed, it has been naturalized, almost anywhere in the world, even the Arctic area. So those are they are originally from tropical, subtropical area, like the Amazon, like the South America. But usually, they have been naturalized relatively easier. But you go back to the 1800, none of them is from tropical, subtropical area. But if you look at the recent 4 invasives, the swallow bladewort, the water hyacinth, and hydrilla, and the parrot feather, they are all from tropical and subtropical area. Okay, so you look at this, data, like 2.5 years ago, look at, oh wow, there are more and more here. You basically are coming to Massachusetts in a relatively shorter period of time, relatively speaking. And the new arrivals, they are all tropical and subtropical species, right? So then you may ask, well, how they come here? Well, it's very difficult to, accurately to address or document how they come here. Everybody knows, right? It can be many, many reasons. But for freshwater species, my friend, Amy Ferreira and her colleagues, they just show us some of the, boating activities in the state of Idaho, which is in the Pacific Northwest, because that's the only data I have. You can see every single state, they go to Idaho for boating, because that's one of the key reasons that why freshwater invasive species are spreading, because of boating, the recreational boating mainly, not like commercial maybe, but mainly recreational boating. So, and of course, at that time, we know, especially in our region, usually those either, the plants or animals, they have some type of thermal limit or thermal tolerance, right? In this case, it's a lower thermal tolerance, which means that below which they are not going to survive. Well, but why there are so many tropical, subtropical species now, not those historical species, right? So there's a reason here. Another reason is that the temperature. look at this Blue Hill Observatory data from like very early 18 more than 140 years ago. You look at the blue dot is the minimum winter temperature in Massachusetts, air temperature. The green dot are the average temperature annual for Massachusetts. So whether you do a just a simple linear regression or the non-parametric trend analysis, it's very clear the temperature in Massachusetts is warming. So it's not surprising, right? This has been documented by many research scientists, like for the air temperature, ocean temperature, and the lake temperature. So that's the same thing. So that's why another reason why there are more tropical species here means that they are able to come to Massachusetts, but now they are also able to establish their population with a sustainable, habitat for them, which is one of them is a relatively higher temperature. And there are many research they have talked about this, invasive species and climate change. Especially here, we are in the great, northeastern risk, group that we know that's going to happen, or that has happened already. And among all those, factors, confounding factors, climate variables, summarized as one of the primary predictors. And Dr. Janica Allen and Dr. Bethany Brownie, they have published their research 10 years ago. So on this issue, when 2016, that's the year when Northeast Risk just established funded, right? And in their publication, they clearly telling us that the Northeast is a hotspot. But I'm surprised that 10 years ago they have they know already. But now I just look at the data 2.5 years ago. Oh, that's true, absolutely right. So a great job. Really appreciate all this great work. So that's the summary, is that more invasive species coming to Massachusetts fresh waters, but most of them, if not all, at least now the 4 recent ones we found are all tropical and subtropical species. Well, thank you very much. I'll try to answer your questions. Thank you.
Great. Thank you, David, for that presentation. The boating travel graph from Idaho was particularly impressive. Unfortunately, we don't have time for live questions, but perhaps if you have questions for David, you can put them in the chat and he can answer them there.
Well, thank you.
Okay, so we'll move into our next talk, which is going to be from Nicholas Stevenson, who is a Northeast Invasive Plant Management Team member and Natural Resource Specialist with the National Park Service. And he's going to talk about new and emerging invasive plants in the Northeast, insights from a regional management team.
All right, good afternoon, everyone. Okay, how's that looking?
Unfortunately, we are not seeing anything. It looks like you're... Oh, yep, that looks great.
Okay. All right, good afternoon. Thanks for the introduction. My name is Nicholas Stevenson. I'm the team lead for the National Park Service's Northeast Invasive Plant Management Team. Real quick background, we're a small team based out of the Delaware Water Gap, which is in Northeast Pennsylvania, kind of Northwest New Jersey, but we work at national park units all the way from Delaware to Maine. So that kind of brings me to sorry, stand by. Okay, sorry. So that brings me to the purpose of this presentation. Since we covered this wide range of habitats across states and climates, it's kind of a good opportunity to highlight some emerging invasive plants that managers further north in particular might not be familiar with, at least yet. So I'm not going to be covering better known plants like stiltgrass or swallowwort, even if those aren't yet ubiquitous in the region, but I'm going to focus on some that might be unknown to managers, or at least less known. And these tend to be more common in the southern parts of the East, but we've been observing them spreading north. And all of these have exhibited some concerning red flags on their invasion potential. And these are all going to be mostly terrestrial plants for this presentation. So this will be brief. I'll try to make up a little time and covering these 4 plants listed with a few bonus ones listed at the end. The first species I'm going to cover is Sericea lespedeza. That's Lespedeza cuneata. Sometimes it's called Chinese bush clover as well. As you can kind of see in the picture, this is a semi-woody upright forb that grows kind of 3 to 6 feet and can be in a dense stands. This is in the pea family, so it's got kind of characteristic pea flowers. It's also got a purple center usually. And these occur in 2 to 4 groups of 2 to 4 along the stem, which then become small pods. Also characteristic of the pea family, these have those 3 parted leaves with kind of wedge-shaped bases. And the stems are gray to green with lines of hairs down them. The leaves can be hairy as well. Sericea lespedeza is usually found in meadows or roadsides, other open spaces. And right now it's a major problem in parts of like southern Pennsylvania, New Jersey, and further south. I'm going to have a series of these maps up. So the gray kind of represents the current distribution, according to EdMaps at least. And the orange is the potential future habitat. Doesn't necessarily mean it'll be terribly invasive throughout that habitat, but you'll kind of see a common theme of most of the Northeast could be potential habitat for these plants. All right, next up is linden viburnum. This is a woody shrub which can grow to be about 10 feet tall. It's a bit similar in appearance to the native arrowwood viburnum. That's Viburnum dentatum. Linden viburnum is Viburnum dilatatum, which is kind of confusingly similar sometimes. They both have kind of the characteristic opposite tooth leaves you see a lot of viburnums have. But the linden tends to be wider towards the end. And it also has characteristic fuzzy stems, buds, even young leaves, petioles. These eventually form clusters of white flowers, which then become clumps of kind of red berries. And these tend to persist well into the winter, even into January. If you're in doubt on the identification of this species, the berries are a good way to do it because most native viburnums have black berries when they're mature. Also, when you kind of get an eye for this species, the bark is sort of dark brown reddish with orangish lenticels running on it. And this is pretty distinctive too. It's currently only well established in New Jersey and some parts of Pennsylvania, and in a couple spots in southern New York and Connecticut. But again, models kind of show that a lot of the Northeast is potential habitat. And I have seen this forming some pretty dense stands in the understory of forest canopy. So that's kind of unusual for some invasives. It's not just an edge invader necessarily. All right, the next plant, which has kind of become a bigger problem in recent years, is lesser celandine. This is Ficaria verna. Sometimes it's also called fig buttercup. Here in the photo, you can see it forming a solid mat, kind of in a riparian forest in New Jersey. Notice that the leaves are just coming out on a lot of these canopy trees. Lesser celandine is a spring ephemeral and a perennial spring ephemeral in the buttercup family. So it actually emerges early, as early as December or January, and then flowers usually in March or April. I actually saw the first flower here in Northeast Pennsylvania last week. So to kind of put your timelines in order. It has these kind of characteristic buttercup flowers. If you look closely, it kind of has a dark center though, which can be one way to tell it apart from things like true buttercups in the ranunculus genus or marsh marigold, for instance. And also it forms a solid mat, which those other species do not do usually. It has kind of violet-like leaves too, which are fairly distinct. This is probably the most widely distributed one I'm talking about today, but it's still an early detection find in many areas, and it's not known by all managers. Look for it mostly in like riparian woodlands, usually under canopy. And the easiest time to see it would be right about now, kind of late March to May. And it's worth noting it vanishes by June usually. All right, the final one I'm going to talk about is silvergrass. This is Miscanthus sinensis, sometimes called miscanthus or Chinese silvergrass. This is a perennial grass that grows in these large, distinct clumps you can see in the image. It usually has a silver stripe running down the leaf as well. And when it does go into flower and seed, it has these real distinct silver plumes that come up. This is widely used in landscaping. It still is available in most places. And because of this, there's some variation you'll see in it as well, such as ones with variegated leaves or banded leaves. Sometimes you'll even see different colored inflorescence. This is another plant that's usually seen in meadows. If you drive in southern Pennsylvania or New Jersey, you'll see it all along the highways. But again, we've been finding it more and more kind of in places in New York and Connecticut and further north. This can spread by short rhizomes, but it will also escape by seed. So some people will sometimes argue that their planted miscanthus is not going to escape, but you know, down the road in a natural area it might. Okay, those are the plants I wanted to cover in this brief presentation. I did throw a list of some additional ones up here that you might want to at least become familiar with. These are all ones that seem to be spreading and are issues further south mostly. That's
Great,
it. Thank you.
Thank you, Nicholas. We did have a couple of questions in the chat. The first one has disappeared from my little document. But it was about, do you expect to see any sort of range shifting invasives arriving into new areas, displacing existing invaders in those areas?
That's a really good question. I don't know if we actually know that for most of these species. And it's worth saying real quick too, that just because the range says maybe it can spread through the entire Northeast doesn't necessarily mean it'll be as bad of an invasive in like the spruce forests of Maine or something. But yeah, I'd love to know that answer. I can't say for sure. I would say it might vary from species to species.
Okay, great. Thank you. And so we're out of time now. I think there are a couple more questions for you in the chat. But in the meantime, I'm going to move us along to our final presenter of this session, who's going to be Allie Putnam, a postdoctoral research associate with the University of Massachusetts, Amherst, and Boston, to talk about recent detection and establishment of the manila clam in New England. And Nicholas, you may need to stop sharing your screen before Allie can get in there. Yeah, thank you.
All right, can folks see my screen okay and hear me all right?
Looks great, sounds great.
Okay, all right. Hi everyone, thanks so much for being here. My name is Allie Putnam. I'm a postdoc at UMass Amherst and at UMass Boston, and I'm on the leadership team of the Northeast Risk Network. I am a marine ecologist working on invasive species and climate resilience of marine invertebrates and seaweeds. And so today we'll be talking with you about salty marine invaders, specifically some recent work documenting the detection and establishment of the manila clam, Rudotapes philippinarum, for the first time here in New England. This is a species with a really extensive global invasion history, and what we're seeing now represents its arrival in the Northwest Atlantic and its completion of its journey around the global Northern Hemisphere. So the manila clam, Rudotapes philippinarum, is one of the most widely introduced marine bivalves in the world and goes by many names such as manila clam, asari clam, and the Japanese carpet shell. Today, I'll be referring to it as Rudotapes. Despite its most common name, manila clam, This species actually does not originate from Manila, Philippines. It's native to the Northwest Pacific, originating from waters around Japan, Russia, and northern China. And it's now established along the Pacific coast of North America, the Atlantic coast of Europe, and the Mediterranean Sea and elsewhere. And a big reason for that is aquaculture. Ruditates is one of the most valuable cultured mollusks globally, about $7 billion annually, actually. Only salmon and white-leg shrimp are more valuable across marine species. And because of that, it's been widely transported and farmed outside of its native range. So this photo on the top here, can you all see my mouse, hopefully? This photo on the top here is showing you some innovative methods of harvesting in Washington State, United States, where farmers are using a modified tulip bulb harvester in this photo. And on the bottom here, we're seeing collection and seeding of farmed areas in Italy, which is one of the European leaders in Ruditates clam production. Ecologically, this is a burrowing intertidal and subtidal clam. It lives within the upper sediment, usually the top 10 to 15 centimeters, and can occupy a wide range of substrates from sand to mixed coarse cobble, as seen in this photo here by Seattle Times. This species has a planktonic larval stage, shown in this clam life cycle diagram, where as a veliger, it is able to move throughout the water column and travel via currents and water flow, enabling its easy spread. This is a broadly tolerant species. They are very adaptable and can tolerate large temperature, dissolved oxygen, and salinity ranges. And so one important point of our work is that it's actually pretty easy to identify. It has a very distinct shell pattern and morphology with this cross-hatching, where we see these vertical and horizontal striations. So we've got this cross-hatching mark. And then it's got this interesting dark patches of brown across the shell, along with gray and white and this kind of vanilla-looking color. It has short, partially fused siphons, as seen in this photo here. And really, there's nothing in New England that looks like this species. And so just to emphasize that point, here is a comparison with some of our common native clams, Mercenaria mercenaria, the hard-shell clam, and Maya arenaria, the soft-shell clam. You can see that both of these native clams do have horizontal banding, but no vertical ridges, like with Ruditates. And these clam species are usually gray, white, and sometimes this dark gray-blue hued color seen with Mercenaria. Whereas again, Ruditates has this distinct color difference and the vertical and horizontal ridges that I mentioned. So once you know what you're looking for, it stands out pretty clearly, which is important when we're thinking about community detection and reporting. This is also a species we pay attention to because of its ecological impacts. In other regions, it's been shown to outcompete native bivalves, alter benthic communities, and act as a vector for parasites. Ruditates has been shown to have a higher growth rate and faster rate of growth to reproductive maturity than native clams, as seen in this graph here by Maya et al. Comparing Ruditates philippinarum to a native species. This high growth rate and high reproductive success gives them the advantage to compete for space and food. And so in large abundances, they can increase bioturbation and impact planktonic communities through their filtration and feeding. And at the same time, Ruditates can become integrated into food webs as prey. For example, it's been found as a prey item to important bird species, such as this oystercatcher shown here, where in the United Kingdom, its effects has reduced the predicted overwintering mortality of oystercatchers by acting as a food resource. And it's also a food resource to an economically important swimming crab, the gozami crab, which is a widely fished crab in Eastern Asia. Many other crab species, gastropods like moon snails and whelk, and even raccoons, opportunistically eat and or rely on this clam as a food resource. So with that context, that brings us to New England. For a long time, this species has sort of existed as a question mark here. There were occasional observations, but no clear evidence that it had actually established. It's been on a regional watch list for years, so certainly a species thought about and watched for in the past. There have been scattered reportings going back decades, some shells, and an occasional isolated living individual thought to be bait and or restaurant discards, but nothing that clearly demonstrated a reproducing population. So the key question was always, is this species here? Is it not? Is it just showing up occasionally? And that's when things started to change recently. Oh, unfortunately, this photo got shifted. It's supposed to be over here. So that's when things started to change, as seen in these photos of Manila clam being documented in Squantum in 2024. But actually, beginning around 2023, shellfish harvesters out on Cape Cod began reporting an occasional live clam. And then at the same time in 2023 and 2024, we were starting to see these occasional Manila clam ruditates shells in Boston Harbor. And the number of observations started to increase into 2025, enough that it really prompted a closer look. So with these increasing observations, we wanted to understand whether this species was actually establishing in the region. So we approached this using multiple lines of evidence. This included reports from shellfish harvesters and agencies, our own shoreline surveys and targeted sediment sampling, and then community science data from iNaturalist. And we combined all of these different data sources and activities to build a picture of where this species is actually occurring. And when we map those observations, we see that this isn't just a single location. We're seeing occurrences across northern and southern Cape Cod, throughout Boston Harbor, and upwards into the North Shore. So with that spatial context, I'll now walk you through what we actually found at these different locations. Starting with Cape Cod, shellfish harvesters documented over 50 live clams across multiple towns like Provincetown, Wellfleet, and Chatham. These were found alongside our native species like quahogs and softshell clams, and were fairly large in size, ranging from 31 to upwards of over 70 millimeters in shell length. And most importantly, when individuals were dissected, we observed reproductive tissue, as seen in this microscopy photo of a female clam with ripe oocytes here circled along empty post-spawned oocytes, indicating that these clams are reproductively active. And in Boston Harbor, we observed over 130 live clams in just 2025 alone, in the last 6 months of the year. These were found across multiple sites like Squantum, Calf Pasture by UMass Boston, Spectacle Island, so out on the Harbor Islands, and the southern portion of Boston Harbor at Webb Memorial State Park. And so individuals spanned ranges of sizes, like adults, upwards of 40 to 50 millimeters in shell length, to small juveniles like this 4 millimeter youngster on my fingertip in the bottom right photo. And one of the strongest pieces of evidence on reproduction in Boston Harbor comes from the targeted sediment sampling that we conducted. We recovered juveniles in the 2 to 6 millimeter range. And then we also found newly settled clams that are around 500 and under micrometers. And so that's really key here, because that indicates recent reproduction and recruitment also happening in Boston Harbor, as like in Cape Cod. We also documented spread beyond Boston Harbor. Live clams were found on the North Shore in Beverly, Massachusetts, which represents the northernmost record to date. Beyond Beverly, we've only observed dead shells, minimal in number. We did conduct some other searches in southern states like Rhode Island and Connecticut, but did not detect any live clams and actually did not find any dead shells. Oops. So iNaturalist data helped add additional context, as we've heard many people over the last 2 days use iNaturalist in their work. So in our iNaturalist data, the first Atlantic observation was actually in New York in 2020 and 2021. This was thought to be food discard or bait. And then followed by records in 2022 in Dorchester Bay Basin, which is in the Boston area. Since then, over 200 observations have been recorded in Massachusetts, mostly in 2025. With only 6% of this iNaturalist data coming from our actual targeted surveys, so suggesting a broad presence. Many of the records are of shells, but together they help document the growing presence of the species. And as a result, there's actually a growing number of live individual entries on iNaturalist since our iNat analysis done at the end of December of 2025, shown here. So when we take all of these observations together, the next question is, what does this tell us? Putting it all together, we have multiple indicators of a reproducing population. We have adults across all of our sites. We have reproductive individuals and newly settled juveniles. Interestingly, in 2023, an eDNA survey in Boston Harbor did not detect this species. And although, but it did detect the native bivalves like Maya and Mercenaria. And so the eDNA doesn't necessarily confirm that Rudotapes was not anywhere in the harbor, but when we take that into account and consideration with the increasing number of detections in 2024 and 2025, the following years, in addition to now confirmed presence in nearby adjacent areas to where the eDNA sampling occurred in 2023, this evidence suggests that this is a relatively recent establishment rather than a long-standing undetected presence of Rudotapes. So a question commonly asked is, how did they get here? And there are a couple of possible introduction pathways. One is ballast water, which is when water is taken up by ships for stability in one port at a geographic location and then released at another port in another geographic location, often carrying larvae or other small organisms. Given the amount of shipping traffic into Boston Harbor, that is a plausible pathway. Another is the live seafood and bait trade, where clams are transported for consumption or fishing and may be accidentally lost or discarded. And then there's also the possibility of intentional release. For example, those trying to establish a local harvestable population, although we have no direct evidence of that or for any of these pathways. So while we can't definitively say which pathway is responsible for the introduction, these are some possible mechanisms based on what we understand about these types of biological invasions elsewhere. And one of the next steps of this work is using genetic analyses to better understand where these populations originated from. Looking ahead, this species will be entering new communities. It may compete with native bivalves. It is also likely to be incorporated into local food webs. We've already observed evidence of predation, including drill holes from a moon snail, as seen in this top photo here with this drill hole, and damage consistent with crab predation, as seen in this bottom photo where we're seeing chipping along the edges. And so one question that naturally comes up, especially given that this is an invasive species and climate change meeting, is how does climate change fit into this? We cannot totally speak yet to if and how climate change may have played a role in the species' arrival, but we can think about future implications of climate change for this species. So first, Rudotapes has a relatively broad thermal tolerance, which means it can persist across a range of thermal conditions, from being found in freezing temperatures amongst ice in Northern Europe to warm waters of the Mediterranean Sea. Southern New England already provides a relatively warm habitat where summer water temperatures can be seen up to 26 degrees Celsius, and the Gulf of Maine, we know, is one of the fastest warming marine regions globally. So conditions are increasingly favorable for both survival and expansion. And because this species has planktonic larvae that can remain in the water column for a few weeks, there's real potential for dispersal once populations are established. So while we're not sure that climate change is part of the cause of introduction, it will likely play a role in facilitating its spread. And so this is something that we will all need to think about as we continue to monitor this species and the Northeast coastal marine system at large. And so one of the things I want to highlight is that this is a very collaborative effort from the very start. As soon as we started seeing more of these clams, Jim Carlton here from Williams College, whose career centers around marine invasives and has been a plenary speaker here at the Northeast RISC Symposium in the past, he has an extensive history with this species and so helped wrangle a whole group of us together who were all kind of independently noticing similar things. So from there, we started sharing observations and comparing notes and trying to figure out what was going on. We also put out a Be on the Lookout, or a BOLO, through networks like the Massachusetts Coastal Zone Management's Marine Invader Monitoring and Information Collaborative, MIMIC, and the Boston Harbor Ecosystem Network, and as well as the Northeast RISC listserv, which really helped expand awareness pretty quickly. And that outreach ended up connecting us with additional collaborators, including Jeff Clements from Fisheries and Oceans Canada, who contributed a lot of the iNaturalist data work. And at the same time, shellfish harvesters were continuing to report observations to agencies like the Center for Coastal Studies in Provincetown, which were really critical in understanding where these clams were showing up on that part of the state. And together, many of us academic and community researchers from places like MIT, Smith College, URI, and Salem Sound Coast Watch were out and are still out conducting sampling to understand the population dynamics and its occurrence through the seasons. This photo here, we were sampling last month and it was 30 degrees, pretty cold. So altogether, this has grown into a collaboration across 16 different affiliations, which is what made it possible to document this so quickly and across such a broad area. So to summarize, we believe rudotapes are now established in Massachusetts as supported by the clear evidence of reproduction and recruitment and size ranges through adults. Our evidence points to this being a relatively recent introduction that is already spreading across the Massachusetts region. We were able to detect this early stage invasion through collaboration. And so finally, what happens next really depends on continued monitoring. This is a window where we can still track and try to better understand the trajectory of this invasion as it is unfolding. And that's actually a rare opportunity in invasion ecology. Usually we find an invasive species and it's there and you're like, oh my God, this is crazy. We're at the beginning stages, actually. And so I'll just end by saying that everything I've shared today is part of a manuscript that's currently in review at Biological Invasions, bringing together our observations, our field sampling, and collaboration. So if you're interested in the details, the methods, data, or digging deeper into manila clams, rudotapes, I'm happy to share that paper once it's published. And again, this was very much a collaborative effort across institutions and communities, and so I would just like to acknowledge and thank my co-authors and contributors and take any questions.
Thank you so much, Allie. Unfortunately, we are scheduled for a break starting at 2:05, so I'm going to suggest that you take any of the questions for you in the chat. In the meantime, it's a great time to run to the bathroom or grab some water, and I will see you all back here at 2:10 for our final talk session of the symposium. Thanks to all our presenters.
The likelihood that it's going to be established in a new environment, right? I want to bring up a system that we're working on as an example. So this is the brown widow spider, scientific name Latrodactylus geometricus. It's a highly invasive species of the brown widow spider. It's in the same group as the black widow spider, but it's less threatening to humans. There are around 30 species in this genus, but this is one of two that seems to be invasive, and this is globally invasive. You can see it in the map. So if you look at the map, the original records before 1920 were in South Africa, and then starting in 1950, you start seeing the records of these species pop up across the globe, right? They have been reported sporadically in Maryland, in Pennsylvania, New York, and New Jersey, but it's still not clear whether these are reproducing and established populations there, or if it's just like random movement. We do know from previous studies that this species is highly dispersive, seems to thrive in urban and disturbed habitats, and that invasive populations are larger in body size and they have more dispersive behavior. They can disperse further. So this kind of explains why it can spread so easily. There are examples also of many places across the globe where brown widow spiders have been outcompeting with native spiders, including endemic and newly described species in Israel, Colombia, Hawaii, and Los Angeles. We can talk more about later if you guys have an interest in knowing about that. But the main question here is how it is successful once it gets to a new place, right? What factors facilitate its establishment? Well, in this case, it's very interesting because there is a common natural enemy for the spiders in this genus Latrodactylus, which is called Philolemma latrodacti. It's a parasitoid wasp that parasitizes the egg sacs of spiders in the genus Latrodactylus. This wasp infects all species in the genus, but previous studies have shown that in the invasive range, the native species are much more parasitized and geometricus than the brown widow spider. As you can see in the figure, here is showing in the arrow a locality in this study where it was found lots of egg sacs of the brown widow spider, the invasive species, but none of them were parasitized, while you find egg sacs of all the native species being way more parasitized. Why is that happening? Well, there are some studies that have shown that brown widow spiders have morphological and behavioral defenses to parasitism, which may be missing in native spiders, and that's why the native spiders are being impacted more by the parasite where the brown widow spider is. Sorry. So aside from being highly dispersive and thriving in disturbed habitats, this host-parasite interaction may be promoting some sort of enemy release where native spider communities are being impacted by the presence of the parasite more than the invasive species, right? There is a lack of a comprehensive documentation of this invasion across the globe and this process of interaction, how it is shaping this invasion. So that's what we're trying to do in this project. We're using two main approaches to do that. We're using population genomics data from both the invasive species and its associated parasitoid wasps, so we can study the history of the co-invasion. And with this data, we want to see things like the relationship of populations and genomic adaptation during invasion and answer questions like how are populations related, what is the native range of the species, and what is the timing and the number of invasion events and the route of invasion events that have happened in this invasive species. At the same time, we want to have an idea of how this invasion will play out in the future and what will be its impact on the native spider community. So under the assumption that the brown widow spider is a better competitor overall, as we have observed, we are utilizing species distribution models to infer presence and future range for a species. And as some of you may know, these models are basically use the climatic information of our species is to infer the ecological niche and then forecast where areas will be suitable. It has been used largely with invasive species to forecast how they will spread in the environment, but fewer studies have combined more than one species to highlight the areas that competitors may interact, right? So we're going to use this approach here to ask what are the areas in the future where invasive and native range will overlap and the native species are more at risk of being displaced. I'm gonna briefly go over some results of these two parts, the phylogenetic relationships and some of the models that we made so far. This is a project that is ongoing. So we collected a lot of data for both the invasive species and its parasite, global sampling, many specimens, and we did a subgenomic representation sequencing of the information, looking at variation across the genome. And here we are trying to understand the phylogenetic relationships among populations to infer the native range and the source of invasion. At the same time, we use species distribution models. We collected records from GBIF, a lot of them from iNaturalist, which has been documented the recent invasion of the species in the US. We use Maxent to model the present and the future distribution of the species, and we did that for the invasive species and for 4 native species in the US, which is shown here in this figure, their scientific names, the pictures, and their overall distribution, with two of them being here in the Northeast, right? One of them being endemic to Florida, which is pretty interesting. Here, we did in the model, we featured our model for the invasive species using the global impervious surface data set because this species has been seen only in urban habitats so far and not in the natural areas in the United States. And the goal here was to infer the areas of overlap as regions where the probability of presence of both invasive and native species was above 90%, both in the present and in the future. So we've been very restrictive here and just trying to focus on the areas where the probability is really high that they're going to be coexisting and native species may be displaced there. Some preliminary results, since I have 3 minutes left. With our genomic data, interestingly, we see a phylogenetic tree where we currently have data for three regions, the US, South Africa, and Israel. And the first interesting thing that we see is that South Africa is highly diverse, which suggests it is a native range of this invasive species. You see a lot of genetic diversity at a very narrow geographic space when compared to the United States, for example. Second, the populations from the US are very closely related to populations in green here in the north of the South Africa region. So that suggests that is where they came from. And third, all populations in the US are very similar genetically, which suggests there was a single and very recent invasion event. So here we found the native range and the source of this US invasion. And for the maps, I'm going to go over them in the time that I have as much as I can. We did maps for the invasive species, right? And this is the map that we see for the present, the predicted suitability of the species in the present. And you can see that warmer colors here represent a higher probability of the invasive species being present. So these models are showing that the species is largely associated to warmer climates in the southern US and Central America, but possibly moving in the East Coast and the West Coast, moving upwards a little bit. It might be a little warmer enough for it in the present. And then when we look in the future, we see that the future range will increase across the southern US and also towards the northeastern US. So here I'm showing two maps. One is an optimistic scenario, and another one is a pessimistic scenario. One is like low warming, and the other one is a lot of warming in the future. This is around the year 2050. And it's a little hard to see, but there is an increase, especially in the northeast, of the probability that you're going to find this species there. So the environment is getting more suitable for the species in this area. I did a little close-up of the northeastern region to be able to show that more clearly, to show the potential northern spread with warming temperatures. And I wanted to focus these arrows here. You can see West Virginia, southern Pennsylvania, central and northern Connecticut. They are not so suitable in the present on the left side, but they start to get more suitable in the future for these species. Yeah, and also in southern Ohio a little bit. And finally, we have some areas of potential future overlap with native species. And I wanted to highlight that with this approach, we are able to highlight these areas where they're both going to overlap, which is important to highlight the regions where the native species are going to be more at risk in their entire range. The top one is the optimistic scenario. The bottom one is the pessimistic scenario. And I just wanted to highlight real quick that these are the regions where the invasive species is going to be overlapping with each of the native species, and they are more likely to be displaced at those points. For the sake of time, I can answer questions about these maps, about locality later on, but I wanted to just highlight take home and future directions. The brown spider has arrived in the US from a source in northern South Africa. It is native range, and in one civil and recent invasion event. It's mostly distributed in warmer climates in the south, but its range is expected to expand northward due to the rising temperature. The predicted future range is expected to overlap with the future range of native spiders in the same genus. It is possibly going to lead to decrease in the population size of native spiders in those localities. And we want to integrate population genomic data with the species distribution models in the future, do agent-based models to predict population size, landscape connectivity, and possible adaptation to climate change in the future using these two sources of information that we have. And with that, if you have time for questions, we may not, right?
Yeah, unfortunately, we're running a little bit behind schedule, but it looked like there were a few for you in the chat. So if you'd be so kind as to check there, we can start our final presentation of this session from Joaquin Nunez, Assistant Professor at the University of Vermont, to hear about phenotypic and genomic evidence of adaptive tracking in wild populations of an invasive Drosophila fruit fly. And
Hi,
we can
folks.
see your slides.
Excellent. If I put on the slideshows, can you guys see the slideshows?
Yes, that looks great.
Okay, wonderful. So yeah, I'm just gonna jump right into it since we're running a little bit behind. So before I tell you a little bit about some of the analysis that we've been doing on Drosophila suzukii, I want to take a second to acknowledge members of my lab whose work will be highlighted as part of this presentation, as well as our funding sources, NSF and EPSCoR, as well as my collaborators, Katie Lauderhos at Northeastern and Nick Tietz at the University of Kentucky. Okay, so in general, my lab is sort of interested in tackling sort of fundamental questions about the evolutionary dynamics of rapid adaptive evolution. By this, I primarily mean sort of cases where we can quantify adaptive divergence happening in a few generations as opposed to, hundreds, thousands, or sort of millions of years or generations. And specifically, I want to tell you about some of the insights that we've learned, sort of applying some of these techniques that we primarily have developed for model organisms like Drosophila melanogaster, but thinking on invasive species, particularly the invasive fruit fly Drosophila suzukii. So I think Drosophila suzukii has a reputation by itself, but if you're not aware of Drosophila suzukii, they are quite a very recent invader to the United States. Usually it's considered that sort of the early 2010s, late 2000s was the time when they enter the continental US. And since then, they have spread all across the United States and also other places, including Europe. Now, what's interesting about Drosophila suzukii is that unlike its cousins, most of other Drosophilates, they don't just lay their eggs in sort of decaying fruit on the ground, but they actually have a series of traits. The females, for example, have a number of traits where they can identify fruit while it is still on the branch, right? And then they inject their eggs into the fruit as they developed. And then as the eggs hatch and then the individual fruit fly sort of eclose, that of course creates tremendous amounts of agricultural damage to self-berry crops. And in addition to that sort of property that makes them invasive, they're also famous for being extremely hardy, because depending at which temperature the egg, the larvae, and the pupa develop, they can eclose in either a winter specialist, which is very cold tolerant, versus a summer specialist, which has a much higher level of heat tolerance, right? So the argument is that this combination of traits makes them really, really good as an invasive species. Now, the way that we're approaching sort of understanding the sort of genetics and evolutionary dynamics in the species actually starts from one of the classic frameworks of recent invasion, right? So under this classic paradigm that adaptive evolution is a really slow process, for a case such as Suzukii, which is a very, very, very recent invader, the classic sort of theory suggests that the toolbox available to this organism to deal and conquer this new environment primarily emanates from a combination of relaxed purifying selection, right, which is dealing with genetic load, as well as with pre-existing phenotypic plasticity, right? Under this framework, there should not be a big role for sort of rapid adaptive evolution. Nevertheless, in other species related to Drosophila suzukii, we're seeing a lot of evidence that suggests that organisms like Drosophila, or Drosophilates in general, can actually start locally adapting to their environment very, very quickly through this mechanism of rapid adaptive evolution, particularly rapid seasonal evolution. And so we wanted to test this hypothesis, which we believe we've sort of litigated successfully in Drosophila melanogaster, but with this species. So the way that we did this is we started collaborating with some of our friends down in Kentucky. And then for 4 consecutive years, we took seasonal samples of wild-caught Drosophila. So basically, you can grab the infested berries, bring them into the lab. As soon as those berries eclose, you have a population of individuals that would, in theory, could have been born in the field. And then we take those individuals and then we survey them for a host of traits. In this particular case, I'm going to tell you about critical minimum temperature, which is an ecologically important trait. That is the minimum temperature at which organisms can remain physiologically competent. Then after we do that, we then propagate the populations 4 generations into the future under common conditions. And then those F4, those 4 generations in the future, we then survey them for the same trait. And then comparing the parental versus the F4 generation, we can ask questions about sort of the impact of plasticity versus rapid evolution. And then we also save all of these flies for genomic sequencing. And again, we do this at different points throughout the season for 4 consecutive years. So now I'm going to show you the results of this work. So on the x-axis here, I'm going to show you the temporal sample, and on the y-axis, I'm going to show you the critical minimum temperature. So if we look at the data, what we observe is that over time, we see evidence of the critical minimum temperature changing very quickly as the seasons progress. This is not particularly surprising. This could be consistent with their evolution or plasticity. Early in the season, flies have very good cold tolerance because these are the survivals of last year's overwintering cycle. And then as the summer begins to roll around, they are selected or they experience different conditions, depending how you think about it. And then they lose either that cold tolerance or they start expressing phenotypes associated with less and less cold tolerance. Okay, so now to understand whether this is rapid evolution or plasticity, we need to repeat these experiments in the F4. So the general hypothesis is relatively simple. If we observe a line that basically has a positive slope, that's actually, and this is counterintuitive, right? Because usually that means plasticity. Well, in this particular case, that actually means rapid evolution, because what it means is that every time that we went out into the field and then we sample individuals, what we were getting was a different seasonal genotype that was selected for a different optima, right? Whereas if we do these experiments on the F4 and we observe a straight line, which means that it doesn't matter what the parents were doing, if the offspring now have a different have the same phenotype, then what that would mean is that what we saw in the field was basically just plasticity, right? At least that's the general hypothesis. Well, lo and behold, we actually see a little bit of both, right? So in the F4, we observe a line whose slope is actually quite similar from the parents. That's actually consistent with the idea that there is rapid evolution. So we're in fact sampling different seasonal genotypes as the time goes by. But also the y-intercept is different, which suggests that there is also a plastic component to the response. So basically at this point, we're actually quite confident that these organisms, even though they invaded quite recently, they're already engaging in the process of rapid adaptive evolution. So they have already began to locally adapt to their environments. But remember, we also had, and this is the last thing that I'll say just really quickly, we also had the genetic data. And so the same way that we were able to test this hypothesis at the phenotypic level, we can then ask the question, if we look at the genomes of these organisms that we sample over seasonal time, and we look for mutations across the genome that are changing in constant and consistent ways, sort of tracking the changes in the seasons, do we observe evidence of this sort of rapidly evolving seasonal mutations? So on the x-axis, I'm showing you position in the genome. Each one of the facets, it's a different chromosome. And then the y-axis is evidence for that. And I see it right there. So I'm going to close right now. And then the short answer is we do see a large number of mutations in the genome of Drosophila suzuki with strong evidence for seasonal rapid evolution. And the ones that concern us and also excite us, depending on how you think about it, is there's a few genes related to insecticide resistance, particularly CYP6, sort of cytochrome P450s, and then also genes related to olfaction. Okay, so then long story short, at this point, we're quite convinced that despite the recent invasion, these organisms are experiencing rapid adaptive evolution. So they are already optimizing themselves. There's plasticity, of course, involved. We never contradicted that. But the identity of the genes related to insecticide resistance and olfactory may actually suggest that these organisms may be able to escape a variety of the sort of currently proposed management methods through rapid evolution and positive selection. And I think we're out of time, but I'm happy to take questions via the chat if there are any. Thank you, folks.
Great. Thank you so much to all of our presenters. I see there's still some conversation happening in the chat, so please feel free to keep that going. In the meantime, I'm going to hand it off to Shika, who is going to present our Northeast Risk Impact Award.
Right. Thank you. Great talks so far. As you said, my name is Shika Singh, and I'm a member of the Northeast Risk Leadership Team. And I'm excited to present the 2026 Northeast Risk Impact Award, which does honor individuals and organizations within the NE Risk Network who have demonstrated exceptional passion, dedication, and leadership around invasive species and climate change. And this year, the recipient is the Ash Protection Collaboration across WAPANIC, APCAW, APCA, which is a group of Indigenous and non-Indigenous researchers, tribal members, and forest caretakers working together to bring more awareness to the cultural and ecological significance of brown ash. First Nation, state, federal, and non-governmental partners have been working collectively for about 20 years to understand and mitigate ash health issues throughout the Brown Ash Task Force, including emerald ash borer and climate change. And this organization continues and amplifies this work by identifying research-informed strategies to protect brown ash that align with the Wabanaki priorities and current research. And today, we are fortunate to have Dr. John Daigle with us to accept the award on behalf of APCA. He is a citizen member of the Penobscot Nation and professor in the School of Forest Resources at the University of Maine. And at this point, I would like to give the platform over to you and have you say a few words. And we're so appreciative of all the work that you and your organization have done. So thank you.
Oh, thank you, Shika. And thank you to the nominating committee for this award. It is a very special award given the members that make up this network, with the state, federal, nonprofit, research. It really means a lot, I think, to the APCA group with the work that we're doing and who we work with. We've had the good fortune to present at your meeting, and hopefully we can continue that into the future. And again, this network is such a valuable entity in terms of sharing research and networking with each other. That's where we met other collaborators to work with when we presented a few years ago. So again, it's made a real impact. I just wanted to reflect on a couple things, being part of this meeting this year that I think really resonates well with the work that we're doing with APCA. And again, for ash trees in Maine, most of the ash trees are still healthy in our state. But we know when EAB kind of gets into those areas, there's going to be rapid mortality. So, the work that we continue to do is really important. And I want to say the research that's being done is so important to inform some of our actions currently and into the future. And I really resonated with Jesse and Chris's presentation yesterday at Acadia National Park, where they're advocating multiple strategies to look at the effects. And again, that's what's being done right now in terms of some of the research and some of that assessment in terms of is it making a difference takes time, and we won't know for years. So again, some of our work is long term that we view, and some of our collaboration is increasingly involving youth in terms of our efforts, whether it's the Wabanaki Youth and Science Program here in our state or high school programming to get them involved in forest health and invasive species. I did want to put in the chat. Let's see if I can do this here. Just a few links. But if maybe somebody could help me while I'm talking. But in the chat, you can look at our APCA website to see some of our partners. And some of those partners involve the Gulf of Maine Research Institute, where we've been working with other kind of building that capacity for outreach, where they've been working with high school groups. And our APCA has been involved in some of those educational efforts. And you can look at that Gulf of Maine Research Institute website as well, search ash trees, and you'll see some of that work. And also you can check out the Sustaining Ash Partners Network. Again, our involvement with other partners in New England and the Northeast. Again, some great work and some trainings that are going on. I think over the past few years, there's really been some growing momentum of collaboration. And I think that's exciting, you know, and I'm hoping that some of our work together can make a difference. Um, I want to just acknowledge the team from APCA. Ella McDonald is actually in Akwesasne in New York, working with some of the tribal members there on some efforts there, looking at storage of ash trees. And Zoe was in New Hampshire last week, working with Nate Siegert and some APHIS scientists looking at EAB biology and some of the things that we might be seeing in our state compared to southern Maine to northern Maine in terms of biology and reproduction. And just acknowledge, you know, all the folks that we work with. It really, it's a joy to work with folks, and especially my tribal community members who have been with us for the past 20 plus years and still so involved because, you know, ash trees are such an important part of their of our lives, identity and basket making and so forth. But they have been a strong advocate. And I'll stop there because I don't want to take too much time over Tony Lynn Morelli, a good friend, with her closing remarks. But thank you again. I appreciate it.
Thank you so much again. And you know, I had the opportunity to visit your website before to prep for this, and a lot of great work. And I'm really excited that you mentioned youth because they definitely are our future. So with that, I'm going to pass it off either to Jenica, who's going to pass it on to Tony Lynn, or do I go directly to Tony Lynn? I'll leave that chain of command.
I can probably jump in.
We can
Tony Lynn.
pass the mic almost directly to Tony Lynn. Just a reminder that Tony Lynn Morelli is an ecologist with the USGS and the Northeast Climate Adaptation Science Center, and was one of the 3 co-founders of RISC, and is here to close us out for this meeting.
Awesome. Thank you. I am honored to follow one of my favorite professors in humans, John Daigle. So this is awesome. Also, I love this part because I get to just kind of like glory in the end that we did it, we're successful, and I get to just highlight all the great things that happened. So this is what we did today. I'm gonna assume that you saw either the day yesterday or the summary of it. But first things first, this is our chance for lots of applause for our symposium planning teammates. So let's put those out there. You're going to have to do this once more today, but this is our penultimate time of saying thank you to this amazing team that put this amazing meeting together. So thank you to these folks, and then everyone else that's been helping, running, making sure everything is smooth. We had a whole bunch of great presentations today. We started out with Tani Smiski reminding us that UMass Extension is out there doing great work for us, ready to help. We got to be in the field with Winslow. That was amazing, doing his real deal restoration work. So hopefully you saw that. Is not go to notwe.com. Winslow also reminded us that we can all donate $1 to Northeast RISC, that it's an easy decision. So the link is there. I'm sure it's soon in the chat too. And I think we have another reminder coming. We then had an awesome session. So I knew about this stuff. I'm on the leadership team and I'm one of the co-founders of RISC, but also just seeing it play out, Matt and Thomas and Bethany telling us about the new RISC tools. I saw a chat that said, is this the same thing as you presented last year? And I was like, no, this is a whole new thing. So it's just so awesome to see everything coming out. I remember when we put the first Climate Smart Gardening product together, the management challenge, in like 2018 or something. And it was one of our most beloved products. And I'm sure this one is going to be even more useful and wonderful. And it has this great web interface that they talked us through. And then Bethany talked to us about the regulatory lists. So much great stuff to check out there. There we are working through it. They even gave us time to work through it ourselves. I thought it was very brave to have 100 people test out your tools in the moment. So that was awesome if you were there for that. It didn't seem to totally break, so that was great too. This was what it looked like. This was the folks kind of together testing it out. We also heard about new things to look for. So learned a lot about looking for like laurel wilts, and moved into sort of the invertebrate section of our day, I think. This was great from Nicholas Stevenson for what to keep an eye out for. And if I'm not mistaken, those are Jenica Allen's maps. So that was exciting to see too. And then Allie reminded us about the salty species. And yeah, we fully moved into an invertebrates focus of the day. So focused on some mollusks here and some arachnids and some great quick talks that we got through. So thank you for all of that. I feel like, I know that I had one other slide in there, which I'm not finding, but I will make a comment about it in a minute. And so, yeah, and then we closed off with Drosophilids, which was great. And then we had the Impact Award. So thank you to John for the work that you and your partners have been doing. We've been doing these Impact Awards for about 5 years or something. So it's really fun to acknowledge people's hard work. And kind of in that vein of looking back, first, I guess I'll look out. So I wanted to let you know, hopefully you know, that this risk is part of a big network we call the iRisk network. And there are risks all around the continent and in the Pacific. We have gotten word that there will be a South Central risk soon and a Southwest risk soon. So there's 6 of us now. There's soon to be 8. It's really exciting. We meet all the time. We now have a whole listserv, which I can drop in the chat if you want to join the cross risk listserv, because there's information from Canada that's relevant. There's information the Southeast that's relevant, and others. We've done webinars with the Northwest, for example, on EAB. So there's a lot of sharing to be done. We really feel like that's an important part of what we're doing. And we've had a lot of successes. So we've had this IRIS network coordinating for about 5 years. So we have lots of members and workshops and papers we do together and presentations, et cetera, et cetera. So just like we have our year in review in the Northeast, we have a year in review across the whole network. So the last thing I wanted to say was that I've been thinking, and you might have heard me say this to David, who I had a slide for David, but I'll mention you here. So this is our 10th anniversary of our RISC Symposium. This is from the report. Our reports are now look more like this, but we used to do it like this, like a 5 or 10 page PDF. This is, you can see at the bottom, it says July 21st, 2016. We met at UMass campus. You can see like some old logos and where we started as partners. So it's our 10-year anniversary. This is what it looked like. We used to have big meetings in person. Now it looks like this funny Zoom thing. This originally looked like 25 people in the conference room at UMass. And I looked up the list of who was there. And at the top, you'll see the 3 founders of RISC, Carrie, myself, and Bethany. And also David's there. So David gets credit for 10 years of having been with us at these symposia. So I think with that, I will pass things over to Jenica. I can keep hitting the button, Jenica, if you want, but I think this is looking at what you've answered in your survey in the last couple of days.
Yeah, thank you, Tony Lynn, and for that reminder that we have in fact been around for 10 years. And it's funny, I don't think we called the meeting a symposium in that very first year, but like, let's count it.
Wait, this way we can count. This is 10 years, and we can also count next year as 10 years.
I like it. A bonus decade, right? But anyway, as we wrap up for this symposium, I just wanted to do a quick, like very non-digested share of the thing that you told us that you've been doing in terms of adaptation for climate change and invasive species. And so like, we're just doing a quick scroll through some of the things that you said, but basically like getting more collaborative, thinking about the language that you're using, using risk tools and reports, choosing resilient plants, thinking carefully or starting to think about what it might mean to have managed relocation or managed gene flow and what information we need about that to do that. And of course, I had to pull out that last one, which was joining RISC. That's what puts stars in our eyes. It's really great that folks are finding value in these meetings and in the network broadly. We wouldn't be a group of over 1,000 people if folks didn't keep showing up and finding value in being in community together and learning from each other, and identifying priorities of information needs, trying to fill those information needs, and rinse and repeat on that cycle. Don't remember who it was that said this, but it feels like we will forever have jobs. And I kind of wish that weren't true, but I think it is. And we've mentioned this a few times throughout the meeting, but we do have this Minute Fund that's available for anybody that wants to contribute to the work that RISC does. In an environment where federal dollars have become increasingly scarce, we are trying to get creative about how we keep things running on the technology side. You'll see we have some server limitations right now. And so figuring out how to improve that capacity over time. And we also get a lot of invitations to bring members of the Northeast RISC leadership team to events to talk about RISC and to talk about invasive species and climate change. And so this fund also, in cases where speakers don't have travel funds or the folks that are inviting us don't have travel funds and it feels like a place that we really should be, we can help people get to where they need to go to provide those presentations. And so, thank you. I can't say it enough times. There will be a post-event survey that pops up when you exit the Zoom. We really would appreciate it if you would fill that out quickly. It should take 5 minutes or less. And it's really all of you showing up and sharing and telling us what you need to know that makes RISC RISC. So thank you, everybody, and we will see you soon.